Ladies and gentlemen, good afternoon and a warm welcome to each and every one of you. With the blessing of the Honorable Founder President Sir Dr. Ashok K. Chauhan, Honorable Chancellor Sir Dr. Atul Chauhan, and under the guidance of Vice Chancellor Ma'am Dr. Balwinder Shukla, Mentor AIES Environmental Institute of MIT Institute of Environmental Sciences, welcome you all today at this beautiful day ahead. We gathered here today at the critical juncture when the climate change looms as an undeniable challenge that requires innovative, comprehensive, and actionable solution. It gives me immense pleasure to proceed with our 1-month certificate course on green technology for mitigating climate change. This course is a tapestry of knowledge, action, and foresight woven towards with 6 crucial themes that holds the key to our sustainable future. Today, we are heading with our theme 5th, that is climate modeling and projections. This section aims to fuel your imagination and inspire you to become a part of the green technology revolution. So let us embark on this enlightening journey together to not to only learn, but to ignite a change, to not just theorize, but to implement it, and not to just discuss, but to empower ourselves and the communities around us. Ladies and gentlemen, as we know clearly, green technology is a term that describes the use of technology and the science to create products and services that are environmentally friendly. Green technology is related to the clean technology also, which refers to product and services that improve the operational performance, while also reducing the cost and energy consumption, waste, or negatives on the environment. Let's proceed ahead. Let me introduce today with our first distinguished speaker for the session, Dr. Atul Kumar Srivastava sir, who is a scientist and officer in charge, Indian Institute of Tropical Meteorology, Ministry of Earth Sciences, New Delhi. Welcome you, sir.
Thank you, ma'am.
Yeah, sir has received a PhD from the Department of Physics from the Pune University in 2008. He joined Indian Institute of Tropical Meteorology, Ministry of Earth Sciences at New Delhi in June 2008. And he's presently working as a scientist and heading the center as an officer in charge in Ministry of Earth Sciences. His main research interests are to understand and quantify the aerosol characteristics and their direct and indirect climatic implications through the measurements and modeling. Sir has published more than 110 research papers in peer-reviewed journals, more than 6 book chapters. He has nominated for the INSA Medal for Young Scientists in 2012 and 13. He has received the prestigious Humboldt Fellowship for working at the Topaz, Germany in 2015. Sir has listed in the World Online Ranking of Best Environmental Scientists given by the research.com. He also has received Best Paper Award during TropMed 2012 and Insta 2018. And he is the recipient of various international grants also. He is the fellow of the Society of the Earth Scientists India, lifetime member of the Indian Meteorological Society, Indian Aerosol Science and Technology Association, Aerosol and Air Quality and Climate Change Research Society. He is a member of the editorial board of International Journal of Geology, Earth and Environmental Sciences. He is the guest editor in the special issue of the International Journal of Sustainability and Remote Sensing. Now, I would like to request the team to please play the felicitation video of the Tulsi sapling, which is an MIT tradition as a symbol of lifelong bonding and friendship forever. We welcome you, sir.
Thank you so much, ma'am.
Dr. Renu Trupar is presenting felicitation video, sir. Over to you, sir. Thank you, sir.
Welcome,
Atul sir.
Thank you, ma'am. So, shall I start?
Yeah, sure, sir. Sure.
Okay, ma'am.
Over to you, sir.
Okay. So I'm sharing my screen, okay?
Yeah, sure, sir.
It is visible?
Yes, sir, it's visible.
Okay, ma'am. So thank you so much. So I'm very much thankful to the organizers for inviting me for this online certificate course program. And thanks for your nice introduction. So the topic of my talk, today's talk is atmospheric aerosols, the unraveling the characteristics and its role in climate forcing. So before going to start, I would like to introduce about my institute to all of you. The IITM Indian Institute of Tropical Meteorology is a premier research institute established at Pune in 1962. It was in under the Department of Science and Technology DST, and since 2006 it is under Ministry of Earth Sciences. The main goal of our institute is to generate scientific knowledge in the field of meteorology and atmospheric sciences, which has potential applications in various fields like agriculture, economics, health, water resources, etc. The major objective of our institute is to understand the monsoon variability and its prediction. Also to understand the impact of atmospheric aerosols on various climate systems. Also to understand the aerosol cloud climate interaction into the atmosphere. IITM has a branch office at New Delhi, near to Pusha Road. So where we are working, and our main objective is to understand the impact of atmospheric aerosols on climate system. So it has two research laboratory. One is at Solapur in the Maharashtra itself. So in the name of KAIPEX, Cloud Aerosol Interaction and Precipitation Enhancement Experiment. And another laboratory is at Mahabaleshwar, which is in the name of High Altitude Cloud Physics Laboratory. The main objective of this KAIPEX laboratory is to conduct co-located airborne as well as integrated ground-based observations at different places to understand aerosol and cloud microphysics region to in the rain activity. Since now it has been conducted in 4 different phases at different parts of India, including Himalayan foothills. The main objective of this HACPL laboratory is to understand the microphysical and dynamical process which involved in aerosol cloud precipitation interactions using various in situ as well as remote sensing measurements. So I'm happy to share with all of you that a new atmospheric research laboratory testbed site has been newly established at Bhopal in the central part of India in Madhya Pradesh. This is the first kind of facility in India, with which is mainly equipped with all kind of measurement techniques which are relevant to the aerosol cloud climate interaction over the core monsoon region. So this facility is very much crucial as per observation as well as modeling is concerned. Now coming to our today's topic. So what are the aerosols? So aerosols are mainly tiny suspended particulate matter, which are mainly in the form of solid or liquid. And because of their liquid phase, it is also known as hydrosols. These are the basic typical type of aerosols. Solid is smoke, fly ash, and dust, and liquid is mist, fog, and smog. These aerosols are one of the most important and certainly the most visible aspect of air pollution, which lies mostly within the atmospheric boundary layer, within 2 to 3 kilometers. And the typical size range of these aerosols are 0.001 to 100 micron. So you can see the wide distribution of their sizes. If you see the effect span of this aerosol, it is also very wide, starting from health, air quality, then radiation, cloud microphysics, ozone depletion, as well as climate change. So all the above effects highly depends on their sizes, mass, and composition. So based upon their sizes, it can be aerosols can be divided into 2 different modes: fine mode and coarse mode. Fine mode are basically the particles are up to 2.5 micron, which is also known as commonly known as PM 2.5. It is further, and also coarse mode is particles which are greater than 2.5 micron sizes. So these fine mode particles are further divided into 2 different modes: nucleation mode which starts from 0.001 to 0.2 micron, and then accumulation mode from 0.2 to 2.5. So this nucleation mode is highly sensitive for the various atmospheric electricity processes like lightning, etc. And this accumulation mode is highly sensitive for this atmospheric optic radiation as well as cloud formation activities. So these fine particles, nucleation as well as accumulation mode, because these are the finer in size, it is highly impact to the human health. However, this accumulation mode as well as force mode combinedly affect the cloud and precipitation physics. So this slide shows the human hair cross section. This further give you an example of how finer these particles are, because if you see the human hair is around 50 to 70 micrometer in diameter. However, 2.5 PM10 is about 5 times lesser as compared to 5 times smaller as compared to our human hair. However, PM2.5 is about 20 times smaller as compared to our human hair. So you can assume their fine sizes. Coming to their emissions, their sources. So there are some mobile sources of these air pollutants, which are also called aerosols, like aeroplane, car, bus, truck, etc. Also, they have some stationary sources like various industries, power plants, etc. And also some area sources are there like urban cities and agricultural activities. Since these are linked with some human activities, so it is these sources are also called man-made activities or anthropogenic sources. Now, apart from these man-made and anthropogenic sources, there are some natural sources which occur naturally, like volcanic eruptions, sea spray from the water bodies, and then forest fire. On global scale, if you see, the contribution of natural aerosols are much higher as compared to anthropogenic aerosols. Why? Because as you know, our Earth is surrounded. Major part of our Earth is surrounded by the ocean, and which is the main source of natural aerosols called sea spray. So on global scale, it is more as compared to anthropogenic sources. However, if you see the regional scale, the things are relatively changed, because this may not be the case on regional scale, especially over the region of which is highly populated and industrialized. So based upon their sources, it can be classified into two types, like primary aerosols, which comes directly from the source, like SO2, CO, NOx, and carbon dioxide, PM, etc. And secondary aerosols are mainly formed from the chemical reactions of these primary aerosols, for example, gas to particle conversion. And it is very difficult to control the secondary aerosol particles, and thus it impacts for a longer time period to our climate system. However, to control overall aerosols or loading, we have to work on primary sources. Now coming to their impact. So aerosols coming from various natural as well as anthropogenic sources into the atmosphere interact with the incoming solar radiation through scattering, absorbing, re-radiation, reflection, etc., which is known as direct aerosol impact. It perturbs the atmospheric heat budget radiation through their scattering and reflectivity nature. Now, this one typical example of this aerosol direct impact, like if we increase the aerosol mass from 7.6 to 65.3, the visibility is degraded. That is the main cause of thing of this direct aerosol impact. Now coming to aerosol indirect impact, where aerosol act as in cloud condensation nuclei to form the cloud. So here I have considered two different cases of cloud. One, aerosols in unpolluted region like clean region, and another case is the aerosols in polluted region. So first I'll discuss the aerosol in unpolluted region. So in that case, clean cloud will form with the abundance of cloud droplet, rain droplets, and ice crystals. So in this case, more number of bigger size droplets and rain droplets and ice crystals will form. And because of their bigger size, the cloud albedo, which is nothing but the reflectivity of incoming solar radiation from the upper part of the cloud, will enhance. And because of their bigger size, it will precipitate more. And if it precipitates more, the cloud lifetime will decrease. Cloud will decay. Now coming to the next case, in the polluted region, polluted cloud will form, and it has more number of smaller size cloud droplets and less number of ice crystals. Because of large number of smaller size, it further enhance the cloud albedo, which is known as first indirect effect. The large number of smaller droplets will increase the cloud albedo. It is called first indirect effect. And because of their smaller size, it will precipitate less, because everything means the cloud droplet will come to the earth surface due to gravity. So because of their smaller size, it will precipitate less, and less precipitation will increase the lifetime of cloud. This is known as second indirect impact. Also, in another scenario, because these clouds are formed in the polluted region, so there is a possibility of presence of more absorbing type of particles within this cloud. So more absorption will take place within the cloud, and that will increase the evaporation of cloud droplets, because cloud droplet means it will form with the water droplet. So because of heating, because of absorption of sunlight, it will start evaporating, and because of evaporation, cloud burning will take place, and this will decrease the cloud lifetime. So it is known as semi-direct effect. So in the same cloud, there are two different cases. Due to less precipitation, cloud lifetime will increase. However, due to large absorption, the cloud lifetime will decrease due to cloud burning. Okay, now if there is a source, there is a sink. So because of various scavenging process, the aerosol will suspend into the atmosphere, and due to this is largely depends on their sizes. So bigger size of droplet will settle down fast due to gravity. However, smaller size of particles are suspended into the atmosphere for longer time period. Hello.
Yes, sir.
It is audible.
Yes, sir. You are
Okay.
audible.
It got muted.
Yeah. You are
Anyway.
audible.
So coming to the dry deposition and wet deposition, because these are the scavenging process. So dry deposition can be divided into two parts: gravitational settling, like when particles are settled down under the gravity forces, and then turbulent deposition, which is the most effective transport process into the atmosphere. So this is the satellite imagery, which clearly shows how this transport turbulent deposition will take place. This red dot you can see is the agriculture burning takes place at the northwest part of India during the October and November period. That you can see the emission is situated in this region. However, their effect may be felt throughout the northern belt of India. Why? Because all the smoke coming from this agriculture burning is spread throughout the northern belt of India. So we can say the source of pollution may be at one place, but their impact may be felt elsewhere. Now this is another example of dust transport, which occurred over the urban region and then impacted in the northern part of India and also in the Pakistan, and also at Himalayan foothills at different time period. Okay, second is the wet deposition. It can be based upon their removal technique. It can be divided into three different parts, like washout process, sweep out process, and rain out process. The washout process is when the particles removed by the cloud droplet formation, which is already discussed in the previous slide as a as an aerosol indirect impact. Sweep up process is the process where the particles present beneath the cloud, because not all the aerosols are acting as a cloud condensation nuclei. The aerosols which lies below the cloud will remove by the rain activity. Whatever droplets, raindrop will fall, that will suspend it through the rain droplets. However, the rain out process is the process inside the cloud. It occurs within the cloud, where the particles removed by the rain droplet, by the attachment of rain droplet. Okay, now why these aerosol studies are important in our climate system? Actually, our climate system consists of various greenhouse gases and aerosols coming from different natural as well as anthropogenic sources. Now, the imbalance of emission of these greenhouse gases and aerosols may perturb our climate system. One example is which we are facing is global warming, which is nothing but the slow rise of mean earth temperature because of enhancement of these greenhouse gases and anthropogenic aerosols, which may lead to a consequences such as increase in atmospheric temperature, reduction in glacier, then sea level rise, etc., which may ultimately affect our Earth's climate system through the impact of our water budget, water cycle. This can be understood with this image. Like the major energy source of our Earth system is sun, which evaporation takes place from the water body as well as from the plants, and water go in the form of vapor into the atmosphere, and that will condense at a certain level, and then cloud formation will take place. Then again, it will precipitate in the form of rain and comes back towards the Earth's surface. So this is the whole water cycle. The enhanced global warming, because of increased level of aerosol and greenhouse gases, may create an imbalance to this hydrological cycle. Because when these anthropogenic aerosols and greenhouse gases will increase more, the precipitation somewhere it is large, it will precipitate more, and sometimes at some places it is the condition of drought. So this way it will perturb our whole climate system. Now, this the IPCC why aerosol studies are important. So based upon this IPCC Intergovernmental Panel on Climate Change report, you can see the third, fourth, and fifth assessment report. The level of scientific understanding for greenhouse gases are very well known now. It is very high. However, for aerosol study, it is still low. So that is because of inadequate measurement of aerosols on regional as well as global basis, and poor understanding on their role in our Earth radiation budget. Thus, the proper assessment and understanding of aerosols are very much essential to reduce their uncertainty in various direct and indirect climate forces. So these are the various measurement techniques. So that can be done on global basis or regional or local basis using remote sensing technique or numerical modeling. So in this talk, I'm mainly focusing on this remote sensing technique that can be divided into three different parts, like ground-based measurement, airborne, which is also known as in situ measurement, like measurement through aircraft or balloon sonde, and then spaceborne measurement through satellite. So I'll briefly introduce you about, since this is the refresher course, so I'll introduce you about the instrument which has been used for aerosol measurement. So these are aerosol samplers, PM10 and PM2.5, which measures based upon filter, quartz filter. It measures the total mass of PM2.5 and PM10. This is an example of filter before sampling. You can see it is very white, and after sampling, after 24-hour sampling, based upon our objective, we can run the take the filter sampling either on 8 hours or 24-hour basis. And we also have some unique instrument called 8-stage cascade impactor, because our previous samplers were provide the information only about PM10 and PM2.5 at a time. But this instrument, cascade impactor, will provide the information simultaneously at 8 different sizes, starting from 0.4 micron up to 9 micron. So after sampling we get the sample over the filter paper. We take some part of this filter to analyze, apart from their masses, analyze the various chemical composition like cations and anions using this IC, ion chromatography. So we get the chemical composition of mass constitution of water soluble species like cations, fluoride, chloride, nitrate, sulfate, and anions like sodium, potassium, calcium, and magnesium. Also, some part of these filters is used to analyze this organic carbon and elemental carbon using thermal technique through OCEC analyzer. This is an unique instrument which provides the information about highly absorbing species, which is known as elemental carbon, which is also called black carbon. So this is also an instrument called ethylometer, which measures black carbon mass concentration at 7 different wavelengths from ultraviolet to near infrared. So it is used to the spectral properties of this black carbon is used to discriminate the black carbon emission sources, whether it is coming from biomass burning or it is coming from fossil fuels. Okay, we also have one instrument like called optical particle counter, which measures aerosol number size distribution in 16 different bins, starting from 0.23 to 20 micrometers size. So it has some limitations because it cannot be operated in high humidity condition. So we usually kept it in the box, having where all aerosol are passing through the silica gel to dry the particles. One unique instrument we have is which measures the scattering properties of aerosol, because previously ethylometer and OCEC analyzer provides information about the absorbing characteristics of aerosols. However, this instrument called nephelometer provides the information about scattering properties like total scattering and backscattering coefficient at 3 different wavelengths. Okay, so these previous slide shows the instrument which provides near surface measurement. However, this is a unique instrument called sun sky radiometer, which provides columnar information about the aerosol using sun as a source. So it gives an information about relatively important columnar aerosol optical properties like aerosol optical depth, which is nothing but the total aerosol loading into the atmosphere, then water vapor, then angstrom exponent, which provides the information about whether the particles are in small size or core size. The typical threshold value of this A is if it is less than 5.5, it shows the particles are in bigger size. However, if it is greater than 0.8, it means the particles are in small size. It also has some unique technique to get the inverse aerosol properties like single scattering albedo along with its size distribution, which gives the information about particles nature, whether the particles are in absorbing type or scattering type. So SSA varies between 0 to 1. 0 means it is highly absorbing type of particles, and if SSA single scattering albedo values are near to 1, it means the particles are highly scattering. I'll show you some results which we have gathered, identified with this instrument, so you can make you understand. So this is also an instrument, a unique instrument which measures the incoming solar radiation. So the solar radiation comes into the atmosphere after crossing like refracted, then scattering, and measure their intensity. This is the case for clear sky day. You can see the high intensity were observed in the afternoon time, and if you see the during the hazy or qualitative sky day, the patterns are same, but the magnitude is about 30 to 40% reduced, which is either absorbed or scattered back towards the atmosphere. However, this is the case for cloudy sky. Okay. We also have this ceilometer, which works on laser-based technique. So it has a transmitter which transmits the laser and this laser gun is interact with the cloud and then reflected back towards the receiver. If it is multiple cloud, this also can be detected using this instrument. And apart from this cloud layer, it can also be also detect the haze layer, which occurred mostly during the winter period by this technique. Okay, so in the previous slides we have this bulky. All the instruments are very bulky. It is very difficult to move from one place to another place. However, there are some handy instruments which can be used for the field camping. Well, first is called the sun sky radiometer, multi-channel sun sky radiometer. It has two components: sun photometer and ozonometer, which provides the columnar integrated spectral optical properties of aerosols along with ozone and water vapor. We also have this micro accelerometer, is the mini part of this big accelerometer, 7-channel accelerometer, which provides the information about highly absorbing black carbon aerosols at single channel, like 880 nanometer. These instruments can be used for the airborne measurements. We have done some camping mode measurements during the winter period, winter fog camping period through balloons only. Okay, now coming to the result part. So I have divided into three different parts: near surface aerosol characteristic, columnar aerosol characteristic, and then aerosol characteristic in the upper atmosphere. So this is the before going to the result, this is the orographic nature of Indo-Atlantic Basin region. Our IGP region is situated in the northern part of India. It has complex nature of aerosols and high loading because it is surrounded by different emission sources like crop biomass burning, dust storm activities, dust storms, then forest fire. Apart from this, local haze and smog. It has also unique topography surrounded by Himalayas to the north, and then Arabian Sea to the west, and Bay of Bengal to the east region, which makes the region hotspot for aerosol research. Delhi is situated somewhere here, which is combinedly influenced by crop biomass burning and dust storm activities in different seasons, apart from various local pollution. So deep convection activity, which are associated with the monsoon trough, which is a low pressure region over this region during the summer monsoon period, which play an important role to uplift these boundary layer pollution into the higher height. So this also we have studied, and I'll show you one slide. So these are the basic characteristics, means what Delhi government has done in the previous year. Several preventive measures have been done to curb the atmosphere, to control the pollution level, like shut down the hazardous industries and to ban the use of diesel vehicles which are more than 10 years within the city, and use of low sulfur content of petrol and diesel, and use of cleaner fuel for domestic purposes and transport purposes. Also, some traffic intervention odd even policy was also implemented for a shorter period of time, but still the air quality has not been improved much. Recently, a national clean air program (ANCAP) was launched over the region, which was aiming to reduce the air pollution, mainly PM 2.5, up to 20 to 30% in the year, by the next year, 2024, in the various non-attainment cities, which has the pollution level, which are the most coming under the most polluted cities, and the level of pollution is over the prescribed national standard. So this is the first result. We have investigated, we have studied the CPCB derived air pollution data like NO2, SO2, PM10, and SPM. So you can see their national all the time, except SO2, all the time these pollutants are much higher as compared to their national ambient air quality standards, which are shown with the dotted line, horizontal dotted line. And NO2 was found to be some epoch of enhancement in NO2 was found during the October-November, means post-monsoon and winter period, which is found to be about 27% time exceed to their national ambient air quality. However, PM10 and SPM is most of the time it is higher to the NAQS level, about 87% and 98%. So these are the monthly mean variability of these pollutants over Delhi. So two peaks were observed. One is in summer and one is in post-monsoon and winter. So the summer peaks were highly significant, dominant during the summer for the PM10 and SPM, which could be due to the transported mineral dust during the summer period. However, the secondary peak in October, November were found to be dominated in all the four pollutants, which are found to be associated with the agriculture biomass burning activities taking place in the northwest part of India during that period. So this is the annual mean variability of all the pollutants, except SO2, all the pollutants are found to be slightly enhanced, which was found to be correlated with the total registered motor vehicle in Delhi during the study period. However, a slight decrement was observed for SO2, which could be due to the use of low sulfur content in petrol and diesel, and also the use of cleaner fuel for transport and domestic purposes. We have also investigated their probable sources. So most of the time using this air mass back trajectory analysis. So most of the time air mass were found to be coming from northwest side, which is highly dominated by the agriculture biomass burning sources. Also, we have correlated this back trajectory occurrence with the observed pollutants. And during the northwest side of air pollution, air back trajectory, it is highly correlated with the observed high amount of air pollution over the region. Okay, all the pollutants are have significant effect of over the climate system. So in this study, based upon some modeling technique, we have used this PM2.5 aerosol chemistry data into the OPAC aerosol optical model called OPAC, optical properties of aerosol and cloud, as an input, along with ambient temperature, RH, and other meteorological parameters, which provides the information about aerosol optical properties like spectral aerosol optical depth, thickness scattering albedo, and asymmetric parameter as an input, as an output. Now, we validated these outputs observed from the OPAC model with the measurement. And after validation, we use this output as an input into the SVDOT model, which is a radiative transfer model, which provides the information about radiative forcing at three different parts of atmosphere: top of the atmosphere, surface, and within the atmosphere. And also, it can the heating rate can be calculated from the atmospheric force. So this is the result. So you can see the left different. This green color bar is is for the composite aerosol forcing, atmospheric forcing, and this blue color bar is shown for anthropogenic aerosol forcing. You can see the large difference were observed during summer period, which could be due to the inclusion of transported mineral dust, which are mainly from the natural sources. However, there is no natural sources during the winter as well as October, November post-monsoon period. That's why this difference is very low. So overall, the anthropogenic sources was found to be contributed about 93% and 88% during the winter and post-monsoon period. However, anthropogenic sources was contributed only 54% during summer because of large significant amount of natural dust aerosols. Okay, now anthropogenic aerosols are composed of different species like sulfate, nitrate, organic carbon, elemental carbon, etc. So it is very much essential to know the individual species characteristics. So we have also quantified the optical and radiative characteristics of individual aerosol species using this chemical composition of PM2.5 over Delhi. So these are the aerosol optical depth for total aerosol, composite aerosol, then sulfate aerosol, nitrate aerosol, EC, and organic carbon aerosol, and their associated radiative forcing, direct radiative forcing. So you can see the sulfate aerosols, which are known as highly scattering type of particles, but contributed highest, about 36% to the total aerosol optical depth, total loading of aerosols over Delhi during the study period in 2012. However, the lowest contribution was observed for organic carbon. If we see the radiative forcing in the term of radiative forcing, elemental carbon, which is one of the most radiative absorbing type of particles, it was found to be contributed only 3% to the total PM 2.5, but for radiative forcing, it is contributed highest, about 70% to the total radiative atmospheric forcing. Interestingly, OC, organic carbon, which was earlier known as highly scattering type of particles like sulfate, but we have observed this is the second highest contributor, about 10%, as a warming species among the anthropogenic sources. So, some studies have already shown that based upon chemical composition of this organic carbon, people have shown that some part of organic carbon is acts as an absorbing nature, which is called brown carbon. So this is also one of the unique investigation. Okay, now coming to the columnar characteristics, based upon columnar aerosol optical properties, we have inferred different aerosol types over the Indo-Gangetic Basin region. So we have utilized two different characteristics like fine mode fraction and single scattering albedo, and identified these four different types of air pollutants over Indo-Gangetic Basin region, like polluted dust, polluted continent. This is mixed type of pollution, and then mostly black carbon and mostly organic carbon. And these are the optical properties of each type of particle, which was found to be drastically different for all the aerosol properties like AOD, angstrom exponent, then their volume size distribution, then spectral properties of AOD and SSA. And we have also estimated their radiative forcing for top of the atmosphere, surface and atmospheric forcing for these type of aerosol. And mostly black carbon was found to be observed relatively lesser atmospheric forcing as compared to the other particles, which could be due to the reason of mixing or coating of aerosol, because it is not pure BC. It is a mixed kind of BC. So there is a possibility of mix with sulfate or dust of this black carbon. That's why it is showing relatively lesser heating as compared to other aerosols. Okay, so we have also studied the vertical characteristics of these aerosol particles using Calypso satellite data. So Calypso is one of the unique satellites having vertically down-looking LiDAR system, which provides the information about vertical profile of aerosol. This is a typical overpass of this satellite over our study region. This blue dot is our study region. So this is the total backscattering coefficient was observed from this Calypso. So it is we have found that the enhanced aerosol layer of about between 16 to 18 kilometers, and this line shows the tropopause height, which is around which also varied with this observed aerosol layer. And to understand it more, we have integrated this backscattering coefficient and tropopause height within 15 to 19 kilometers, and you can see the IBC, the integrated backscattering coefficient, was found to be increased from March to September. However, the tropopause height was found to be decreased, and we have also to correlate it with the convection. We have investigated the OLR, outgoing long wave radiation, which is the proxy for surface deep convection activity. The surface deep convection activity was found to be lower, found to be high over the region when IBC backscattering coefficient was found to be large, which suggests vertical uplifting of boundary aerosols into the upper atmosphere. Further to understand this, further to support this, we have also plotted vertical velocity, wind vertical velocity. So you can see during the period when we observed the large enhancement in backscattering coefficient, a vertically uplift was observed during that period, which confirms the probability of vertical transport of boundary layer aerosols up to the upper atmosphere. Okay, so all the previous slide shows the enhanced aerosol loading over the IGP. Apart from their various climatic impact, these aerosol pollutants can also severely impact to the health of the high population over the Indo-Gangetic Basin region. So now with this slide, I would like to show the impact of COVID-19 on COVID-19 on various air quality. Actually, it was well known that the lockdown was imposed worldwide, including India, to stop the spreading of coronavirus. However, during the period, all man-made activities were ceased, which on one side stopped the spreading of virus. However, among others, on the other side, which was never thought over even, improved the air quality of the polluted cities. So many studies have been done which showed the improved air quality during the COVID-19, and they have suggested that the lockdown-like intervention may be used as a possible emergency measures to reduce the severe air pollution episode in India, mostly during the post-monsoon and winter period. So these are the satellite plots in 2019 and 2020. So you can see the differences of these parameters like AOD, then absorption AOD, then AI, and then total columnar nitrogen dioxide. So you can see about 30 to 35% reduction were observed over the Indo-Gangetic Basin region in the northern part of India, which is very high. That is because of it comes because of various anthropogenic activities. However, we have done some phase-wise study because lockdown was imposed in different phases, 4 different phases. So you can see a phase-wise increase in all the air pollutants were observed due to the restriction were eased in each lockdown phases. You can see the PM10 level is increased from 80 to, it crosses the threshold value in the last phase of lockdown. So with this, I come to the end of this talk and the summary and the future direction. The study suggests that the entire IGP region has enhanced aerosol loading with different compositions, which has large spatial heterogeneity in their characteristics and found to have significant impact on our climate system. So there are many aspects which can be taken as a challenge to investigate, like the IGP region is surrounded by different various emission sources. However, proper assessment of mixing and coating of and their morphological study of various aerosol species and their impact assessment has not been well quantified so far. Also, the IGP is experienced hazy and foggy conditions, mostly during the winter period. However, knowledge of possible interaction between near surface aerosols with the occurrence of fog has not been well established. And also the study to understand the possible impact of various aerosol on human health is very much essential over the region like IGP, as high population is under the impact of these hazardous pollutants. So with this, I stop my presentation. Thank you.
Thank you so much, sir, for such an enlightening talk. And you have really talked about your Institute of Tropical Meteorology also and showed us some new research wing pictures. It is so informative to know that. And you have a so much plethora of knowledge about the aerosol, major sink of the aerosol, scavenging process, water cycle. You have talked about the IPC reports also, air quality assessment of Delhi during COVID-19 also, and before that also, an OPEC model also, sir. Sir, thank you so much for such an enlightening talk. And sir, there is some few questions in our chat box also. There is one question, sir. What is the major link between aerosol and climate change, which we as an individual can help to mitigate it?
Okay. Like aerosols, as we know, aerosols are mostly coming from the man-made activity. Apart from if we leave the natural part, most of the anthropogenic sources are from us only. So we can control like one visible example we have already seen during the COVID period. If we reduce the vehicular activity, reduce the industrial activity, air quality will improve. So there are many ways we can improve we can utilize public transport instead of going office or some other place from our own car. So that way, a small step we can take, and that can improve the air
Thank you,
quality
sir,
also.
for answering this question. Sir, another question in the chat box is major link between aerosols and climate is the impact of aerosols in changing Earth's radiation budget by its various direct and indirect effect. Long-term influence on aerosol can cause climate change. As an individual, we can reduce our individual ecological footprints and use resources judicially. Somebody, I think, have given the answer for this question, in fact.
Right.
And sir, the question is actually what she has asked after giving the answer. She has asked that do aerosols after wet and dry deposition enter the water body as well?
Do aerosol?
Do aerosols after wet and dry deposition enter the water body as well? She's asking the question.
Okay, I'm not able to get the exact point what she was trying to ask, but
Maybe she's asking that the wet and dry aerosols
yes,
have different.
because aerosols, yeah, both are different. Because wet aerosols means like if you take the example of fog is also one kind of aerosol.
Yes,
Means
sir.
dry aerosols are there, and their coating of water vapor is there. So that
Yes.
way it can impact.
Yeah. Sir, one last question is smog and fog both are aerosols. In what way they are different? Like you are talking about the same stuff and the individual has asked the question.
Okay. Fog means this polluted fog is called smog.
Okay.
These are the basic difference. Fog is okay, but polluted fog is called smog, which
Yes,
is very dangerous.
Yes, sir. Thank you, sir. Thanks a lot. And you have given such a nice lecture. And actually, I'm also working on COVID-19. So there was insightful lecture. And maybe in future also, I can come to you if you permit us. And I can collaborate with you in my
Sure.
research work also, sir.
Sure. Thank you so much, ma'am.
Thank you, sir. Thank you, sir. Moving ahead, as rightly said by Stephen Hawking, scientists have become the bearers of the torch of discovery in our quest of knowledge. Now I invite our next speaker for today's session, Professor Akhori Pramod Krishna, who's a professor in remote sensing, Birla Institute of Technology, Misra, BITS Misra. He's an MTech from Roorkee University and PhD from Ranchi University. Sir, we welcome you on Amity platform.
Yeah, thank you, Dr. Mufti, and thank you for inviting me.
Yes, sir.
And
Sir,
privileged to be with you on this
Yeah.
certificate course deliberations. So I'll look forward to have a good session with you now.
Thank you, sir. And it's our
Yeah.
privilege also. And I just want to introduce about Sir. Sir is a professor in Department in Remote Sensing, BITS Misra from July 2010. He is an associate professor from Department of Remote Sensing from 2007 to 2010. And now he also worked as a scientific officer in Department of Remote Sensing. He was a registrar also and the head of the department also. And he has associated with G.B. Pant Institute of Himalayan Environment and Development, Sikkim unit, and he was the scientist D also there, and he was a faculty head professor in the disaster management faculty in Sikkim state. And sir have like associated with Cement Research Institute also, and sir have a research area in geospatial technology and remote sensing and geoinformatics application areas like the climate change, snow cover, glacier dynamics, natural hazards, disaster management, natural resources and basin hydrology, planetary remote sensing, and the urban and the built environment also. He is a lifetime member of the Indian Planetary Science Association, Indian Society of Remote Sensing, Indian Society of Geomatics, Indian Society of Technical Education, Indian Geological Congress, Indian Association of Soil and Water Conservationists. So many like lifetime member. He is like with associated also in Indian Society of Ecological Economics, Mountain Forum USA also. He's associated with the Sikkim Science Society also, and he was associated and still association with the Hawaii USA East West Central Association. And he's a member of Institute of Electrical and Electronics Engineering also, and Geological Society of America, GSA, from 2001, and the National Institute of Ecology, India, from 1998 to 2002. Now, I would like the team to please play a felicitation video for Sir for Tulsi sapling, which is an amity tradition as a symbol of lifelong
you.
bonding and friendship
Thank you.
forever, sir.
Thank you
Dr.
so
Dhruv
much.
is presenting Tulsi sapling to you, sir,
Yeah,
and we welcome
thank
you
you.
on Amity platform, sir.
Yeah,
It's our privilege to
I
listen
am so
your
humbled.
lecture.
Thank you. Yeah.
Sir, over
Thank
to
you.
you. Thank you,
Yeah.
sir.
Yes, thank you. So it's a very elaborate introduction that I really did not deserve, because I am here only as a teacher to maybe go ahead with maybe like a classroom teaching and all those kind of accolades that you actually added in your introduction. Maybe it's because of the long span of service, so I could have all that kind of associations. Right now, coming back to my topic here today. So let me just start sharing my screen.
Sure, sir.
Yeah, sure. So straight away without losing any further time. So on this, so maybe, yeah, okay. So I intend covering this. Can I stop my video? If it is, I'll be speaking. So
Yeah, sure, sir.
yeah, thank
Please.
you. Yeah, thank you. So, okay, so yeah, so topic in line with the theme of the session, what I have chosen is climate modeling and projections. That is in one part that we all talk and we are all concerned, but somewhere we actually worry and we want solution, and everything is being talked upon in terms of research and a lot of it which is coming through. But how it started, I think the concern, how it started and what actually, I think some basics wise, if we go, many a times when we actually talk about some climate concerns, usually we come across the reports of Intergovernmental Panel on Climate Change, that latest report as assessment report 6. Maybe it has referred to many kind of findings which are pertinent for our attention as maybe stakeholders of the globe. Global surface temperature, what was the condition 1815 to 1900, that kind of duration, and then now how it is changing. So those kind of concerns, I think the statistics here, I don't want to give much focus right now, but this report is available and anybody can refer. But usually the concern that comes along is based on all the efficient models which are there. And these are basically all models which are simulation based and the kind of numerical models and the models which actually try to kind of give projections and predictions. So whatever is available to us, it is some kind of assessment, past time also, and now whatever is being projected. So these things we come across, but we actually have to ponder about some of the basics also. I think these are something like classroom type. I'm a teacher, so I just was tempted to talk about all this also. Many times we talk about weather and climate synonymously. So I think by and large, the going by the profile of the participants in this course, I don't expect that anybody has to actually learn from me about this distinction, but still we usually have the kind of understanding that when we talk about the weather, this basically we are talking about the state of the atmosphere at some place and time. So, and whereas climate, we are talking in the long term, so that is in the kind of average of weather elements over a specified period of time. So this is how the basics that we start, and then of course what WMO suggests is 30 years of kind of statistical kind of analysis, if it is available for any kind of these parameters of weather, then that becomes something like climate we can talk about an area. So there actually is the starting point, and then I think some of the basics that many of you are already familiar, just as a quick reminder that it is we are talking about day-to-day state of the atmosphere in terms of weather and short-term variations in minutes to weeks. That is what we refer. And people use as a kind of understanding of weather, we talk about combination of temperature, humidity, precipitation, cloudiness, visibility, and wind. So I think these are by and large understood our understanding of this. And we actually talk about changes in weather in terms of near future, how it will be and how it will be like today and how it will be like in the next week, something like that. Whereas climate, when we are talking, is averaged over a period of time. So that is what I told. And then climate information, of course, we talk about the statistical weather information. So this is how actually this grows, and then we actually make our understanding. And then talking about the forecasting of weather versus climate. So basically, I think meteorologists, they focus primarily on real-time kind of data to predict local or regional atmospheric condition for the hours, days, or weeks ahead. whereas weather prediction again leads to be more local and relates to conditions in the immediate future from days to weeks, as we already, I think, have a good understanding. But just to make a kind of this thin line kind of distinction here. And climate scientists, on the other hand, they look at the atmospheric conditions in terms of averages and trends that we actually talk about that have occurred over many decades, centuries, and millennia. So this is how actually we are entering into that domain of talking about this kind of modeling, climate modeling, and then overall kind of temperature change in the atmosphere over the past 8 lakh years. So I think there's some kind of data which is made out, and one can see that there had been kind of climate has changed many times over Earth's long geological history, and over the past millions years, and Earth has already experienced several glacial periods. So that is interspersed with interglacial, that is warmer periods. So what peaks we are seeing is interglacial, warmer periods, and overall relatively constant and favorable interglacial period of climate experience over the. So 8,000 years has made human civilizations advancement possible. So in fact, they're actually the main concern lies. So it is good in a way, but otherwise now the things have accelerating this, coming around to these kind of time scales when we are reaching. And something like when actually the climate and whether we are talking long-term climate data, we are talking. So basically something we all as a maybe layman, or sometimes maybe as a new kind of thing to be known to us in terms of many times we wonder how the data can be made out when it was not recorded. So many times we talk about proxy data with these climate things when we are talking. So weather basically is variable, but can be averaged over a time to indicate climate trends. Therefore, climate scientists, they can use weather data plus proxy data to help them identify previous trends to improve their predictions of future trends. So what are proxy data when we talk? So this is basically data which pertains to maybe in terms of biological, cryological, which refers to frozen water, geological and historical records that scientists use to deduce Earth's atmospheric conditions in the distant past. And by examining evidence such as the tree rings of old growth trees and ice core samples taken from glacier, scientists can figure out what Earth's temperature, greenhouse gas composition, and precipitation levels were like over the course of its geological history. So maybe these are some of the things that actually are as a proxy data, which actually is made out. So that is how in the climate thing, when we actually see a lot of things about the last century, last to last century, things are made out and some comparisons are made. So before actually going on to that part of history and concept, there's some kind of interesting things to note also, that how the tools are used to forecast climate and weather. So we are familiar. So it is almost like a kind of maybe reminding ourselves that weather balloons, satellites, especially designed airplanes and radar and other ground-based collection instruments, they are used to measure wind speed, precipitation, air temperature, humidity levels, etc. And reliable records have been kept since 1800s and in that century, and provide accurate weather forecasts. So after that, maybe during that period, that consciousness came, and then records were being maintained or archived. So, and over nowadays, like in terms of sophistication that we have acquired in terms of our technology, is in terms of sophisticated Earth observing satellites, they are equipped with remote sensing equipment that actually provide kind of record of sea surface and other temperatures, measure atmospheric gases and rainfall amounts, and take visible and infrared photos of Earth's surface and calculate Earth's outgoing infrared and reflected solar radiation. These are all very important components which actually contribute to the understanding of climate studies. And climate, actually, when we talk, it is basically depending on kind of the latitude. So latitudinal position, where the angular distance north or south from the equator. So that is actually how that can be measured along the meridian of that particular point. And then sun rays, actually they vary, and then those areas actually are defined because of that changing climate. And overall, when we talk climate, depends on oceans and bodies of water. So I think that is one of the largest kind of component. And since it is occupying almost three-fourths of our kind of planet, so ocean plays a crucial role in determining climate because of its ability to absorb, store, and transport heat from the sun. And ocean water also affects atmospheric temperature and circulation around the world. And furthermore, any seawater, which is the source of most precipitation. So that's what actually is built in our system. So what terrestrial system and oceanic system we have, out of that one can see. So what block diagram we are seeing is, you can see that large kind of expanse which is occupied by ocean, and lot many activities which take place there. So basically, these are all, in fact, the kind of feed to the overall climate to behave in terms of any kind of static parameter or dynamic parameter, how they can be influenced, and then overall kind of acceleration which is being provided through our kind of developmental activities. So that's some of the things which may be kept in mind. And then again, climate, when we talk, it is again depending on the mountains by blocking paths of air mass. So we already know that because of that hills, kind of that shade which is there, and the kind of this trapping of monsoons and those things. So altitude and biosphere. So these are all, in fact, some things which are a kind of natural phenomena which goes on and in an area, geographical area, latitude wise. And types of climate, when we talk, we already have some idea that we talk about tropical, that is remain high all over the year and shows an annual wide change in precipitations with wet and dry seasons. So I don't go on for defining everything, but moist and dry, and temperate, which is not hot as the subtropical climate, and milder than the polar climate. So it is usually defined, but by what it is not. So it is like something like exclusions there, and then polar, very cold, snowy and windy, and then that lacks warm summers. So I think these are some of the things. And weather, when we are talking, so what meteorologists look at are wind, air pressure, temperature, humidity, and then weather words that we usually talk about: windy, sunny, cloudy, partly cloudy, snow, tornado, lightning, foggy, calm, cold. I think these are some of the common things that we are all aware of: warm, hot, dry, humid, mild, drizzling, rainy, icy. So I think these are all some of the kind of commonly used these words that we have come across. Now coming to this global climate modeling, what actually is the general philosophy of this is simulation of large scale motions of atmosphere, oceans and ice. So this is one of the important component of it. Then solving approximations to full radiative transfer equations, and then parameterize processes too small to resolve. So overall kind of scenario has to be developed. So that way these are very much essential. And overall, when we talk, some models also try to simulate biogeochemical processes which go on. And then first global climate models developed in 1960s. So something like which effort wise one can see that where it started and how things improved, and now whatever kind of changes we are seeing and new kind of models and then predictions which are coming up. And in this kind of models, you usually have this kind of less vertical slices than typical weather forecast models. So climate models, they have less vertical slices than what typical weather forecast models. Here, basically, they are not equally spaced and more levels closer to ground and near the tropopause. Things change quickly at those points. And then there is a sigma coordinate, which is typically used as a vertical coordinate. So actual pressure divided by surface pressure, and that sigma coordinate. So that actually leads to some kind of component which needs to, in terms of consideration of height. So that meter height at what sigma component. So that variation can give some different kind of slicing. So grid spacing in sigma coordinates and the corresponding average altitudes of the levels. Maybe maybe one example that we see 9-level atmospheric general circulation model, which was earlier employed by one of the authors, which is referred here. So as a sample, one can see that these are some of the things. And sigma coordinates, when they're used, basically some advantages are there that they conform to natural terrain. So mountains are represented in models where they will never intersect the ground like a height coordinate, and then simplifies mathematical equation in model. Whereas there are some limitations also. This complicates certain computations, pressure gradient force in sloped regions. So it's not ideally everywhere kind of that verticality. And then sometimes land points extend into oceans due to smoothing near mountainous terrain. So these are some of the limitations, but we'll see as to what kind of vertical component that we are talking. So of course, there are various partial differential equations written as finite difference equations or phrased in finite elements or spectrally decomposed. So whatever way it is derived numerically, but our understanding as maybe in a common way, what we can work out is one can see horizontal grid, that is latitude, longitude. And when we look at the vertical grid, it is height or pressure. So that way it is actually factored, and overall physical processes in a model which is built into this. So that way it is like any model that about atmosphere and overall kind of scenario which is created. So that is the way in which the vertical part is factored. And looking at history of numerical this weather model, this climate modeling, we have to make a reference of maybe Lewis Fry Richardson, who actually gave some kind of idea of maybe numerical weather modeling. So that is, he started with a publication in Weather Prediction by Numerical Process in 1922, which was initially not successful. And then we'll see some example as to what happened. But there was a good effort by him, Richardson's forecast factory that he created. And he actually talked about this phrase that you see is perhaps someday in the dim future, it will be possible to advance the computations faster than the weather advances. So what computations that gadgets were available at that time, that would have been a limitation and overall kind of these facilities, and at a cost less than the saving to mankind due to information gain. So, but at that time, he said that that is a dream. And then weather prediction by numerical process, what he actually talked about is grid over domain, then predict pressure, temperature, and wind. So talking about temperature, then density and pressure gradient, wind and temperature, those kind of factors he started into this. And then one weather prediction by numerical process that he made is that expression that you see here. And what he predicted is 145 millibar per 6 hours, but observed is -1 millibar per 6 hours. So that this is the kind of level of prediction, but at least he started and he published at that time. And as a historical fact, then talking about this ENIAC, Electronic Numerical Integrator and Computer. So that is 1946. So what it was like, 17,468 vacuum tubes, 7,200 crystal diodes, 1,500 relays, 70,000 registers, 10,000 capacitors, and around 5 million hand-soldered joints. Then weight was about 30 short tons, that is equivalent to almost 1 short ton is 2,000 pounds. So maybe less than slightly 1,000 kg per ton. So that is the tonnage. And then that was the kind of weight, and 350 floating point operations per second, that is flops. So that is how it operated. And these kind of things were there. So those constraints, and then, but still going ahead on this, it actually came as maybe first successful numerical weather forecast in April 1950. That is by Jules Gregory Charney. So he actually is an American meteorologist and professor at MIT who played an important role in developing numerical weather prediction. So that is 1950. And late 1950s, first routine numerical weather forecast by US Joint Numerical Weather Prediction Unit that was done. Thereafter, first efforts to regularly collect weather data at surface and upper atmosphere. And then major general circulation modeling effort evolved into the Geophysical Fluid Dynamics Laboratory at Princeton University. So I think this one of the kind of details which has been referred here with the name of the then director of GFDL. So, and early to mid 1960s, ocean models were developed. So that is actually talking about the average sea surface temperatures, and it is overall kind of altitudinal, like longitudinal spread, and latitudinal and longitudinal spread, and then overall roles of sea ice, snow, land processes, and biosphere began to be incorporated into general circulation models, GCMs, that we are familiar with. And then what is in a climate model when we wonder? So basically looking at some components is atmospheric general circulation model when we talk, dynamics, then subgrid scale parameterized physics process, then that actually includes turbulence, solar or infrared radiation transport, and clouds. Then coming to oceanic general circulation model, dynamics mostly. Sea ice model, viscous elastic plastic dynamics, and thermodynamics, a lot of it. Then land model, energy and moisture budgets in biology. Coming to chemistry part, pressure advection, which basically is actually talking about the link to the flow structure study. And then of course, possibly stiff rate equations, which basically are actually talking about maybe sometimes some differential equations have a problem in terms of solution. So it actually that it is some small steps have to be obtained for satisfactory results. So that kind of situation when it arises, so that is in chemistry. And talking about coupled atmosphere and ocean climate model, that actually is now growing and becoming more kind of practically applicable. So here you can see the radiation which is coming through the atmosphere in terms of density, motion, and water, and then overall that you see ocean parts, sea ice, and land. exchange of heat, momentum, and water. So that way the entire kind of coupling is there. And overall physical climate system, when we say, it is like external forcing starting from volcanoes and sun, and we have the atmospheric physics dynamics connected to that. Then we have the stratospheric chemistry and dynamics. And you have the kind of ocean dynamics, terrestrial energy, moisture, water. So these are the linkages that you see. And here, when you see the internal part of it, that is the tropospheric chemistry, pollutants and greenhouse gases. So these are actually marine biogeochemistry, terrestrial ecosystem, soil, greenhouse gases, land use, human activities. So all these yellow colored boxes are showing where you have the direct human effect. So overall physical climate system. So you can see if it is undisturbed and if it is having less influence, then this is the ideal thing. Whereas even within this, what actually are influenced by humans. So that is the domain where we have a concern that the climate models have to factor all those kind of situations where they can have some effect on this overall change of climate or warming, whatever we say. Now, talking about the predicting impacts of climate change, it actually starts from emission scenarios, from population, energy, economic models. So we to start there, emissions, then look at carbon cycle and chemistry models in terms of concentrations, carbon dioxide, methane, sulfate. So this is actually something which is spread out in terms of what way the models are being approached. And then scenarios, some of you might be aware, and these scenarios are actually predicted, or maybe some kind of scenarios which are simulated. So maybe starting with that, but basically everything has to be factored here. Coupled global climate models, when we say the global climate change, temperature, rainfall, sea level, etc. Then talking about the regional climate models, here you have the regional detail, mountain effects, islands, extreme weather, etc. Slightly coming around to the local kind of scale, and then impacts model, flooding, food supply, etc. So basically, these are the main stages that can require that may be required for providing climate change scenarios for assessing impacts of climate change. So that's how this modeling thing. And overall kind of development of climate models, past, present, and future, one can see is mid-70s. It was only being talked about maybe in terms of atmosphere, mid-80s atmosphere, then land surface, early 90s atmosphere, land surface, ocean and ice, and ocean and ice model actually came that actually became maybe in implementation that attempt wise. And overall late 90s atmosphere, land surface, ocean and ice, sulfate, aerosol. Then we started more components to be added onto that sulfur cycle model. Then you have the kind of next part that you see is present day atmosphere, land surface, ocean and sea ice, sulfate aerosol, of course, there, and then sulfate aerosol, carbon cycle. So you can see non-sulfate, and then land carbon, ocean carbon, carbon cycle. So everything added on to that, and overall kind of dynamic vegetation and atmospheric chemistry. It is like lying somewhere, but that is now included in the early 2000s. So that is how it is like overall components which are getting added. So basically, that these are like taken from this assessment report 4 of the 4th IPCC. Okay, and progress in climate modeling, maybe going by assessment report 4. What you saw in maybe mid-70s rains, CO2 we talked, mid-80s clouds, land surface, and prescribed ice. Then we have the first assessment report, swamp and ocean came into the picture. Then talking about the second assessment report, volcanic activity, sulfates, ocean. Third assessment report, carbon cycle, aerosols, water-turning circulation, and rivers within rivers. And then assessment report 4, even chemistry and interactive vegetation. So that's how it has grown. And then now we are into 5, we have already seen, and 6 also. So 6 report is also now out and it is available. So now then overall kind of constraints that is being taught. So 50s, 60s, 70s, 80s, 90s, and 100s. So you can see this kind of computer kind of availability and computational kind of support which could be available. So you can see these how the things have changed. So computer speed and the eras that you see, maybe the decades that you see here. First of you, so machines used by the Met Office. So how they could struggle with those kind of details, which could be very handy for any simulation studies or modeling studies. And talking about the GCM land component, when we talk, this actually has to contain heat and moisture balance equations and the snow cover model. Then talking about GCMs, they have been shown to be very sensitive to surface albedo and moisture characteristics. So surface albedo and moisture characteristics, they're actually very much kind of important component for this. Then ocean component, when we talk, so that is similar governing equations as atmosphere, except oceans are liquid. Ocean basin geometry is more complex. So maybe some in this way. And many important features in the ocean, they are too small to be realized in today's model. So maybe Gulf Stream or shear currents less than 1 degree wide. So maybe those kind of things, but these are actually factored here. Then sea ice model. Sea ice that increases surface albedo, inhibits exchanges of heat, moisture, and momentum, alters local salinity. Then assume ice forms if sea surface temperature less than -2 degrees C. And then also should predict movement of ice. So not physically, but overall kind of simulation and kind of numerical calculations, these are factored. And some of the visuals that you see here about these conditions that are factored. And overall, when we talk unresolved physical processes, that has to be handled parametrically, which is convection, thin and or broken clouds, cloud microphysics, aerosols and chemistry, photochemical processes, ozone, turbulence, including surface fluxes, sea ice, land surface processes. So these are actually all the kind of factors which have to be maybe handled parametrically. And something like talking about the process models and maybe the parameterization, the boundary layer, clouds, stratiform, convective, and microphysics, and overall how it can be parameterized to be kind of extended. So taking other factors into account. So that is what is the scenario, how it is created. Then you already are aware of this kind of cloud conditions, thin and broken clouds, when you have the L2 cumulus cloud. So that basically is the variation of various types in which how they can be present in the area or maybe geographical area. And the altitude wise also. And then low clouds over the ocean, when we say one simulation, if it is seen that if it is change in low cloud with 2 times carbon dioxide, then how the kind of changes low cloud amount will be there. So that is simulated here. So these are 2 models, and the changes which actually were observed is just opposite to each other. So maybe that carbon dioxide impact one can just quickly maybe foresee that how it can lead to some changes in the behavior. Then sensitivity to cloud microphysics, overall kind of pressures and relative humidity that you see. So that maybe the relationship can be there, which has to be factored. Then overall kind of global mean temperature simulation using many different global models, when we say, including all forcings. So there could be maybe in terms of 20th century kind of these efforts, there could be success of simulations. That is in fact is the result of model curve fitting, and maybe the curve fitting that we do after plotting of maybe the anomaly in temperature and different years that we see. And but only like what happens is that models, whatever are created, they actually run because of the natural forcing. So natural forcing has to be there, and if that is also kind of somehow getting a kind of acceleration or some kind of feed due to some activities that we perform, then that also is getting altered. So that is, and observed time mean zonally averaged ocean temperature. So what you see, black contours, and model mean minus observed temperatures, colors for the period 57 to 1990. So in fact, these were earlier kind of studies which were carried out, and then one can see how depth wise the kind of and the latitude, the position of the geographical zones that you see, and then how it has actually factored. So there may be some kind of studies that way were started at that time. And when we talk about, anyway, so that basically talking about these comprehensive climate models. So emission actually is the starting point. So emissions, we talk about maybe concentrations of radiatively kind of active species, comprehensive climate model when we talk, and then carbon cycle climate interactions basically is factored here in this. So radiative forcing and climate response. So that actually is a kind of cycle which goes on here. And based on this, some kind of observations which are there, that actually earlier what happened, that it was observed and projected tests. So sensitivity test wise, But later on, when it became more robust in terms of projection and predictions. So maybe these kind of predictions also started. So projected kind of scenarios for various scenarios which are there, forecast 1 and 2. So maybe by changing the emission scenarios, and then so that is a kind of simulation. So for future, so that is how the forecasting is being attempted. So what scenarios maybe, in fact, today's lecture I'm not going to cover that, but anyway, some scenarios which are already postulated, and if the emission level has to be cut and some level has to be maintained based on those scenarios are prescribed by the IPCC. And the various working groups and reports which are coming up many times. So these are from time to time. So what we are having latest is this AR6. So, but anyway, some of the frequently asked questions at the end of all the kind of these annual reports, these assessment reports which are coming out of these exercises are extreme events going to, like maybe heat and maybe these kind of droughts or floods and these kind of scenarios that these kind of events, they can be expected to change as the Earth's climate changes. So in fact, that is something which is already very much tied up with those changes. So we can say, yes, the type, frequency, and intensity of extreme events are expected to change. In fact, it is not something which is to be said, but it is already being experienced as the Earth's climate changes. And these changes could occur even with relatively small mean climate changes. And such changes in some types of extreme events, they have already been observed. And for example, that increases in frequency and intensity of heat waves and heavy precipitation events. I think these are being experienced. And then precipitation intensity, whatever is shown here, and precipitation intensity in the map form that we see. And overall, in fact, these dry days. So everything which is mapped for certain parts of the years that we see from 1880 to recent year, and then projection also into 2080 and beyond. So these are all actually something which are now being experienced. So that is started happening. And Arctic ice sea also. So there also the sensitivity is there, and then what kind of changes which are there. So maybe some things that which are already becoming visible and a lot of concerns which are there. So and then predictions observed and modeled Arctic sea ice extent. So one can see going by the present rate and kind of parameterization. So Arctic sea level extent, how it is going to be the scenario for 2100. So it is like these are the kind of things which are available through these climate kind of groups which are working and giving the scenarios. And of course, coming to this IPCC AR6. So okay, with every increment of global warming, regional changes in mean climate and extremes become more widespread and pronounced. So here one can see that global warming level. One level that is shown is the last time global surface temperature was sustained at or above 2.5 degrees C was over 3 million years ago. Now the scenario, if the kind of changes that we are seeing in terms of these kind of changes, world at plus 1.5 degrees C, world at plus 2 degrees C, and then world at 3.3 degrees C. So that is above, talking about this level from 1850 to 1900. So that level, if it is taken, and then world at 4 degrees C. So that way, what is happening in different kind of these situations, annual hottest day temperature change, and then it is projected to increase most, maybe 1.5 to 2 times. Then in some mid-latitude and semi-arid regions in the South American maybe monsoon regions. And of course, overall kind of contribution from urbanization and overall intensification of heat. Similarly, annual mean total column soil moisture change, that is also linked to that, and that is also very important. Projections of annual mean soil moisture largely follow projections in annual mean precipitation. But so those are the linked factor. The annual wettest day precipitation change. So that way, in fact, why I'm mentioning all this is like these are the kind of things that we are coming across through all these kind of simulation exercises and modeling. So starting with what was there, and then overall kind of the triangle that we see in any of these attempts and these modelings, that you actually look at maybe theory part, then you look at the data and phenomena, lab and numerical experiment, and this has linkage with the observation. So you look at the data and phenomena, the foundation, then explanation and prediction, then you validate it through observations, and then data. So overall kind of cycle, this goes on. And that is how the models which are actually made available to us and the kind of scenarios and these things are predicted. So I think this is all. In fact, it's like a classroom content rather. In fact, I just had this idea of, because I didn't have the profile of participant, but still I thought that I have to handle this part. So introducing to the climate modeling, maybe some other speakers will be going for more of numerical part of it, but overall kind of approach that we have. So that is how I kind of design my presentation for this course. So that's all. Thank you, Dr. Mufti. Yeah, so I'm done.
So much, sir, for such an enlightening lecture. And you talked about the basic concepts, also about the theme, which is rightly correct. The present theme going in the world also, that is the climate modeling and the projection. And you talked about the basic concepts and their terminologies like the weather and the types of climate, temperature change, numerical weather modeling, and a sea ice model also you talked about, and the climate modeling process also you talked about, the physical climatic system also, and IPCC reports also you talked about, sir. Very nice lecture and very well informed basic concepts and the history about the climatic modeling and projections. Thank you, sir. And
you.
sir, there is a few questions in our
Yeah.
chat box.
Sure, sure.
Sir, one question is, will it be hotter or colder in the future, more wet or more dry in terms of climate change?
Yeah, in fact, this is a very good question. This is what we are all apprehensive of, how it is going to be, because many times we come across, I think I'm not I hope I am not contradicting myself, that we are listening about maybe something like it is a normal cycle that nature has. So we have
Yes,
little contribution, what we are worried, we as a human being and maybe the race which we are. But overall, the kind of acceleration which has been seen in after the industrial revolution, that is what is the concern for entire kind of climate talks that we have nowadays and climate scenarios that we are worried and what we discuss. So going by that, it is certainly warming. So until unless we check ourselves in terms of emission cut, which is not very far from an irreversible kind of point that we are going to reach in maybe within a short time from now. So that is actually if the kind of scenarios which are generated by these kind of studies by IPCC and all. So if, until unless we are effectively doing it, the emission cut and that for reversal of this ongoing climate change, so we'll be in a kind of very tough situation. So it will be irreversible and then will be leading to, I think then it is only pointed at hotter. And hotter means certainly it is going to be less wet. So it is certainly drier, hotter and drier. So more of drought, yeah, more of drought, but you have unusual rains and precipitation also. So then I think seasonal disturbances also.
Correct,
so
sir.
yeah, so changing kind of pattern of seasonal behavior.
Sir has given the answer completely, and I think the student have cleared who have asked the question, and audience also. The another question, sir, is, has the process of global warming in recent years accelerated faster than it was predicted just a few years ago?
Yeah, in fact, the IPCC report, actually, that is the main basis how we are talking about all this. So in fact, that group, when they are doing the extensive study based on a lot of observations, which are improving from one IPCC to another IPCC, because they have more kind of better kind of data and repository and better parameterization, better kind of numerical ways to handle. So I think that way it is improving. And I think I'll slightly just take you to one, it is rather not to be mentioned. So I think maybe in terms of seriousness, but fifth report of IPCC somehow erroneously initially had predicted that Himalayan glaciers will vanish by year 2025. Of course, that was remedied later on, but we see that it is not going to happen. Going by the health of glaciers right now, that is not happening. So, but that is maybe one exceptional case. But yes, the scenario, the kind of predictions which are there in recent times, they are coming true very much, and it is almost like matching with those scenarios. So we are very close to whatever predictions are being made. So that
Thank
is
you,
what,
sir.
yes.
Thank you for answering the question, sir. You have talked about the climate modeling and the projects in a very lucid way, and the audience have been benefited a lot. Thanks for joining us on Amity platform, and we will in future also want to listen your good lectures and your plethora of knowledge. We will definitely share in future also. Thank you so much.
Thank you, Dr. Murthy. That will be my pleasure. Look
My
forward.
pleasure
Thank you.
also, sir. Our
Yeah.
pleasure.
Yeah,
Thank you.
Yeah.
Moving ahead,
So,
as rightly said by Marcus Aurelius, nothing has such power to broaden the mind as the ability to investigate systematically. And truly, all that comes under the observation of life. Now, I invite our next speaker for today's session is Dr. Alok B. Mukherjee. Sir, welcome you on Amity platform. Dr. Mukherjee is a co-founder and director, product and research analytics lead techs, TED India Private Limited, UP. Sir is currently associated with the Dr. Anamika is presenting Tulsi Sapling, and just I want to give a brief review about the sir. What is sir doing, and sir is currently associated. Thank you, sir. Please join us on Amity platform.
Thank you so much, ma'am. And
Sir.
Am I audible?
Yeah, sir, you are audible, and I just want to give a brief introduction about you so that our audience may know what is your knowledge and in what sector you are working. Sir is currently associated with the Nextech India Private Limited as a co-founder and director, product research and analytics. Along with this role, he is also associated as a chief remote sensing GIS analyst and head, Redix division and LED Connect Services Private Limited. Before joining LED Nectech's co-founder and a director, product research and analytics and LED Connect Services Private Limited as a chief remote sensing GIS analyst. He also worked as a chief guest lecturer and a remote sensing specialist respectively. He also been involved in developing space Earth Tech Analytics model for investigating various aspects of the Earth system using mathematical and statistical model, AI, ML framework. He believes in that core research and development activities are an absolute necessity for the success of any product and creating a deep impact. Dr. Mukherjee feels that is important to raise awareness, and hence he has been involved in communicating findings through research-based stories, as this may help in raising awareness. In past, he has also written research-based conferences, articles, many books also, analytical stories also, and sir is doing the modeling and analytics also, mathematical modeling. He's working in the area of mathematical statistics also, Bayesian framework also, and geostatistical modeling, informational techniques, and his philosophy is like the philosophy of India also right now, Vasudhaiv Kutumbakam, the world is one family. And the purpose of his life is the Vasudhaiv Kutumbakam, and we should also work in the green technology also in a same way. According to the Mukherjee, his journey should be directed towards developing impactful solution for people, and he wishes to pass on whatever he learned to those who need it. Sir, I am very privileged to listen your lecture. Over to you, sir. Thanks for coming.
Thank you so much, ma'am, for such a wonderful introduction. And firstly, I want to thank the Amity University management for inviting me to share my thoughts on this very pertinent topic. And good afternoon, respected faculties of Amity University, distinguished speakers, and all participants. Can I share my screen, ma'am?
Sure, please, sir. Move ahead.
Is the screen visible?
Yes, sir, it's visible.
So today, under the theme of this climate modeling, I wish to share my thoughts specifically on this topic, that is game theory-based causal artificial intelligence-driven analytics for climate modeling. And the entire talk will be focusing on this modeling part. And I'll go into the details of this one, that why we are saying, why specifically the game theory-based causal AI, and why not conventional AI. And even the world of climate modeling is also very huge. So what are the use cases, or what is the exact segment that I'm going to choose for this talk? So I'll go into the details of this one. So before I go ahead, I just want to give a brief about my company, that our aim is to become a leading earth tech analytics company. And our actually core aim is to develop solutions which are human centric, and because we do believe that we need to touch the lives of people. And when we are working in the direction of developing earth tech solutions, so this has to be in the context of human centric solutions. It has to touch the lives of people. And as it is clearly visible, I hope that it's visible, the mission of our company, that it is space tech and AI driven next gen product. Means we wish to develop products in these following modules, like climate smart agriculture. So when we are saying agriculture, it's not agriculture, climate smart events, then disaster risk management, weather analytics, landscape biodiversity, forest ecology. We'll be going into I'll be going into that one, that why we are saying this one. And then carbon footprint sequestration, then entire value chain analytics for all the events, not just on agriculture, and then location intelligence. Similarly, specifically, we decided that we need to work on cognitive AI solutions also, and for digital commerce, fintech, and social networks, because the problems that we are targeting as a company, as a team, and to develop some kind of human-centric solutions. So that is not possible if we don't consider the cognitive aspect of the human component. So that's why it is also very much required that we need to have technology which can support this kind of dimensions, aspects. And then advanced means development of analytical products on IoT, drone sat, means the hybrid products using drone analytics and satellite analytics, sensor networks. And similarly, we have been working on that drone analytics also. We have our division also in the company. Now, what are the specific initiatives we have taken till now from on the behalf of Leads Next Tech? What actually Leads Next Tech is trying to do? So very recently, we have taken analytical initiative to perform impact studies in 16 states of India, focusing 7 sustainable development of goals. And those 7 goals are SDGs are mainly climate action, life on land, responsible consumption and production, sustainable cities, zero hunger, partnership for the goals, life below water, clean water and sanitation. So these are the 7 sustainable development goals on which we are currently focusing in these 16 states. And then whatever we will be doing, we'll be releasing the impact reports also, analytical reports also, in the forms of books, in the form of technical reports. So as you can see in the right side, there is like on 24th of September, we'll be announcing this one. Right now, I'm releasing sharing the book over here, that Assam, A Tale of Perils, analytical report on Assam. So we have done a study on Assam. So these reports will be shared. So we'll make it available for whoever are interested in these kind of reports. Plus, we are very soon we are going to launch our research journal also, Ixana. So that journal will be focusing on earth tech analytics. And then I am very delighted, and on the behalf of team also, and I think today International Trade Expo is also going on in Greater Noida. So there also we are revealing our sustainability product, the actionable AI platform PixStack. So I'll be discussing the details of PixStack also here, because how is it related to our theme, to the talk that means the thoughts that I'm going to share, and how is it relevant in the context of our theme today, that is climate modeling. So on that also, I'll be sharing some of the details about this one, and how is it going to change the entire ecosystem when we are discussing in the context of sustainability. So when I would like to segment the entire talk in different segments so that we should have clarity, because as I have already mentioned that my talk will be focusing on development of causal AI models for climate modeling. But climate modeling and projections is like itself is like a world. There are so many things under this one. So basically, primarily there could be many other categories also. So there are many modules like under climate modeling and projections, we can focus on regional climate projections. It itself is like a huge world. Then climate change monitoring, then hydrological modeling, and then climate change impacts and adaptation. So this talk is specifically on the climate change impacts and adaptation, that is in the context of sustainability. So the entire the thing, that the impact of climate change and the factors which is actually triggering climate change. So the entire thing in the context of sustainability. So how can we develop frameworks? How can we develop models? What are the possible approaches? Those things I'll be discussing. So the talk is focused on climate as a domain. If I have to say in the context of theme, then it is focused on climate change impacts and adaptation, that is sustainability in the context of, in the direction of sustainability. And in the context of modeling, it is on the causal AI. So before I go ahead, we need to understand that when we are saying that climate change impacts and adaptation, so as I mentioned that it is in the direction of sustainability. So it is like a very comprehensive system. We need to have deeper understanding, a very comprehensive understanding about different events, because if we need to work on sustainability, so we cannot work, and if we need to work on sustainability in the context of the impact of climate change on the earth events and other dimensions of society also, we cannot ignore the social events also here. So this requires the knowledge of like a number of disciplines. So there are a few names mentioned like agriculture, fisheries, energy systems, very important, human and animal health, transportation, because this is one of the most important component of urban system, and how does it affect the climate change. Then urban infrastructure. It means the crux is that we need to have idea of the deeper understanding of different events, and these events cannot be confined to any particular class, because we need to take care of the ecological events also. We need to take care of the ecology will cover everything. So in the context of physical, we need to take care of the physical aspects also. We need to take care of the social aspects also. We need to take care of the cognitive aspects also. If we are really aiming climate change, we really constitute the dynamics of climate change impacts and the climate action measures which we need to take. Now, the second point, that evaluating all possible climate adaptation measures. So as the entire talk on sustainable development goals and other efforts also that we have been doing like now for many years. So we need to evaluate all the measures also, the climate action measures which we have been talking, because maybe all of the measures may not be relevant. All of the measures may not have the global scope. It may have the local complexity, so that need to be taken care of. But how? So that I will go into the details later on. And then we need to understand, as I mentioned it earlier, we need to understand and we need to consider it without any exception that this world is it's required multi and interdisciplinary approach. We cannot handle this with one discipline, or we cannot handle with this one kind of framework. We cannot handle with a linear approach. Now, so it means till now, for the sake of clarity, that I'm going to speak on causal AI models. And as far as the domain goes, the talk is on climate change adaptation, impact of climate change, and this one. So it means when we say this one, that impact of climate change, so would it be enough if we say that let's do a study and if it is in the context of sustainability, so let's decipher the impact of climate change, maybe extreme rainfall events, extreme weather events. So we can see now right now the recent events in Himachal, recent events in Uttarakhand, or in many places across the world. So would it be enough if we just quantify the pattern? Actually, the story is it's a very cyclic thing. We need to understand that when we decide to do any study on the climate impact of climate change, so it means we are talking about the pattern. It means what we see. We are trying to quantify that one. But why it happened? What are the regions? That is taken care of by the process modeling, process variables. So both aspects need to be taken care of. What is happening? What is the pattern? We need to quantify this one. But what are the regions? What are the factors that triggered that event? So both are equally important. And in fact, if I take the liberty, I would say that we need to be we need to have very focused approach on the process modeling, because if we don't know the factors, if we don't know the impact of those factors on the event, so we may quantify it. We may understand that yes, this much area is prone to landslide, this much area is prone to vulnerable to floods, this is the area vulnerable to flash floods, I mean, so many things. But we may not be able to come up with like a robust climate action measures, because we are not connecting between we don't have the bridge between process and the pattern variables. So we need to have this one. Now, just for the sake of clarity, that when I'm saying process variables, and I'm going to discuss about the strong AI, means if we I'm taking liberty to say it like conventional AI, that talk that ML deep tech we are saying. Then now the next thing that I'm going to discuss about the strong AI. But before that one, what is right now the research, the studies, means what is the pattern of the study? So for that, I am just taking a kind of a huge case, like suppose agriculture, just to explain that what is currently going on. But this agriculture can be replaced with any other event. Then I will move to the core topic of game theory based causal AI. Process variables. So suppose if we need to develop some climate resilient agri-tech analytics platform, if this is the use case, so we can have we can go for any kind of numerical modeling approach. We can go for AI. We can AI frameworks. Fine, it's okay. But first of all, you need to understand that, okay, fine, whatever is the impact of climate change on the agro ecosystem, that is part B. Let's first understand that agriculture as an event, how is it triggering climate change? How is it affecting the environment? Or it's like that agriculture as an event does not affect the environment in any way. But see, these are some facts. That agriculture, it's like global emissions due to agriculture were 9.3 billion tons in 2018. Land cover emissions are 4 billion tons. And I would like to bring it to the notice of the audience, all participants and respected speakers, that agriculture is one of the most contributing factor towards changing LULC patterns also in many parts of the world. Now, drainage and fires of organic soils have been increased by 35% since 2000. Means if we go by the pointers which are available, so you can see on the screen, it means agriculture as an event is also contributing towards climate change. And then the last point, largest driver of deforestation. It means before we construe or decipher the impact of climate change on agriculture, first we need to understand that agriculture as an event, how is it affecting the environment and the ecology. But let's go a little backwards. So agriculture and emissions, but why? So can we avoid this one? But a very simple and a very linear effect. Food demand is increasing. We need to, and one of the SDG, Sustainable Development Goal, is zero hunger. So food security. So we need to take care of the food security also. There is only one way, that we need to have our food ecosystem has to be strengthened. It should be very robust, and it should meet the demand of the population. But when we say it should meet the demand of the population, and the way global population has been escalating, and the way the arable land has been decreasing, and plus not just the decreasing pattern of the arable land. One more thing we need to understand: the land utility, the land quality, that is also decreasing. So it means, first, there is a decrease in the arable land. Second, the quality is also decreasing. The utility is also decreasing. So it is going to affect the overall production. So there is no other way. So then what happens? Fertilizer, pesticides, so many things it's like a kind of a add-on things which we use to enhance the productivity, but it has some impacts on the environment. Next. Now, it is like uh, we have to connect the dots. So energy, water, agriculture, everything is interconnected. So there is a water footprint. The consequence, the carbon footprint of agriculture also needs to be understood. The energy consumption. So we need to means agriculture. Agriculture productivity is very important, but at what cost? There are many things which are interlinked, and it has impacts on the environment. So can we avoid it? No, we can't avoid it. We need to have actually very good productivity, agricultural productivity. But there is a side effect of it, but which we can't avoid. So why am I saying this? These are the factors which is actually disturbing the environmental ecosystem, and then it is actually impacting the agro ecosystem. Now this event can be changed. Agriculture can be changed, can be replaced with some other event also. The same pattern is going on. So now, so if we need to decipher the means, as I mentioned that fine, when we are saying that we need to develop models or need to generate analytics, and we want to understand what is going on. So before I move forward, I want to say just means we all are aware, and climate change and these things are something which is now being felt by everyone. This is not something confined to news. This is not something confined to boardroom discussion. This is not something, if I say, look, we have come up with a model, and right now this model is predicting these kind of things for Gautam Buddha Nagar, but you are not feeling it. So if you're not feeling it, it's a failure. Because now this is something which is being felt, which is being actually now has become the part of everyone's life. So we can't now ignore. So just considering the pattern will not do. We need to understand the reasons also. But what happens with the conventional AI-based system? So that's why before I go into the core of causal AI model for climate modeling, and specifically for this module, that climate change, impacts of climate change and the adaptation measures, and what we can do through technology, what we can do before technology, what we can do through the mathematical foundations and everything. So I will go into the detail this one, but we need to I need to tell the difference. That's why suppose now these are the problems of agroecosystem. Now we have been assigned, or suppose we decided to now address this entire agroecosystem. So we need to take care of the sustainability of agroecosystem. So we are developing a AI-based system for this to strengthen the consistency of integrity of agroecosystem. So suppose these are the steps we are taking. So our idea is that let's make climate resilient agriculture analytics framework a kind of a platform also. So what we'll do means I will not go into the each means the details of each point, but suppose. So within season, we need to understand the phenology, crop phenology, dynamics and everything. Fine, we'll do this one. So stress quantification, we'll do this one. So we know based on the stress dynamics, we'll understand the impact on the productivity. So post-harvest, pre-harvest. So agriculture productivity will do this one. So there are many parameters, crop management parameters will be taking care, we'll be considering, we'll be considering the weather parameters, meteorological parameters. We'll be taking care of the socioeconomic parameters also, because it's very important. If suppose, just for the sake of, because now we'll be moving into the causal AI, so cognitive aspect will come into the picture. So suppose the land is very fertile, everything is very good, but farmer's socioeconomic condition is not good. So in fact, instead of this example, let's take this one. If there is some problem, stress in the land, here if the socioeconomic condition of farmer is not good, so the things which are required, like equipments and everything, which are required to counter the challenges of this, the degraded land utility of the land utility, then we need to compensate with some kind of add-on measures. Farmer will not be able to do it, can't do it, because the socioeconomic conditions is not good. If he doesn't get any help, so it means whatever is available with whatever is possible with that degraded land, that only will be the productivity of that land. So it is going to affect. Now next, suppose when we are targeting sustainability, so we'll take care of the carbon footprint also, that how much water is being used, what kind of electricity consumption in terms of equipment usage. Those things will be taken care of, what kind of fertilizer and this one. Based on these kind of analysis, alerts, advisory and everything we'll do. And climate smart interventions also, because based on the advisory, suppose that right now water stress is being observed, so we need to take care of we need to take care of the irrigation measures. So these are like climate smart technology interventions that will be done. In terms of labels, so we can do like district-wide productivity analysis, then gram panchayat wise also. We can go my block wise also, gram panchayat wise also. We can go to the more granular level also. Transition means if we are predicting high, then can our prediction from high to mod happen? Can it happen from high to low? So we'll do that also. So we'll try to develop a model, a climate resilient model, considering the impacts of climate change. Means in some area this area is most vulnerable to drought. So this is one event is identified, and what could be the impact of drought on the productivity. Some other area is vulnerable to flood. Some other area is vulnerable to like extreme weather, means rainfall events. So in this way, events are identified and the impact will be quantified. Different, as we all are aware that now we can go for like regular machine learning methods also, or we can go for like deep tech this one also, and we can come up with this kind of thing. But we need to understand here one thing. The entire architecture is whatever data is available for the current or historical or everything, no issues. Historical data sets we will also be considering. We will also consider the current data sets also. And then it was fed into a kind of a black box thing. And then some analytics are being generated, but we don't know the regions. We don't know the region. We just know here I would like to mention it explicitly that we should not confuse sensitivity analysis with some causal analysis. That one parameter is very sensitive to other parameter. That's why the output is being affected. This is sensitivity. Can be in the direction of causal analysis if it can be merged with some other parameters also. But we actually really don't know what are the factors actually affecting the entire ecosystem. Reason is that process variables we must have some kind of frameworks, we must have some kind of platforms, models, which can take care of process variables very appropriately, very effectively. Because that quantification, the deciphering of process variables will become the foundation of that climate model. Now, in this only, we can say, and I'm not saying that this will not work. It will work, but where the accuracy will be affected, and what are the regions where it can become vulnerable to errors also, or if not errors, inconsistency. So that I will discuss in the later slides. Now, suppose through this approach, conventional AI method, we'll be doing association analytics. Association analytics means what is the relationship between two parameters when we are studying in the context of some event. Here event is agricultural productivity, suppose. We'll be using satellite-driven analytics, agent-based analytics. We are also considering land system dynamics. Everything is fine. Whether parameters are there. We can take so here I deliberately mentioned causal AI frameworks. So here we have to include, if the causal AI frameworks will not be included, then the impact of the parameter, the bridging between the process and pattern variables will not be possible if we exclude the causal AI frameworks. So why this causal AI is so much important, I will discuss in the later slides. So insights we can have the sowing, harvest estimation, crop health, crop damage, crop age, sustainability score. Sustainability score also we can get it because if the land utility is good, if the crop management practices are good, if the productivity is also good, so it's like a value chain. So all of the models are good, then the sustainability score means in terms of linguistic variable, the sustainability score can be good, can be rated on a scale also. So we can convert it into that also. These are the different models which can be taken care of. I will not go into the details because I will go into the details of the causal AI framework. But suppose what I'm trying to say that when we are adopting or trying to develop a conventional AI system also, then also we are taking care of all the modules. We are not, oh, we don't have any intention or this one that we would ignore those modules. That's why it is effective. No, we are considering all the parameters, but then also it will miss a few things. And what are those things? It will be discussed later on. So here also suppose, so land is there. So before land, we are doing the farmer profiling. Means we are trying to understand the socio-economic conditions, everything. Then farm analytics means based on satellite, based on weather analytics, based on IoT, drone analytics, whatever it is. But all kind of analytics means the utility of the land, the crop management parameters there, what could be the productivity there. So those things will be construed. Next, crop simulation modeling. Stage wise, we are doing this one also. Means at the time of sowing, we are trying to forecast what will happen at the time of harvest. After 15 days, what are the possibilities? So in this way also. Alert system also, if there is any red flag, if there is any problem that we have observed, so we'll release those advices also. In the deviation analysis, you can see in the screen that based on the scenario generation of farm analytics, deviation analysis will be performed to assess the difference in the yield between controlled environment and real-time environment. It means, if I put it in a simpler terms, how is it deviating from the normal scenario? Now, what are the advisories that we can generate to this AI system? Next season cultivation inputs, what kind of inputs need to be taken, carbon management practices, carbon footprint. If it is too high, then it's not sustainable. The value chain is not sustainable. Then there is something wrong. Maybe right now we may have a very good productivity, but the carbon footprint is not taken care of, so sooner or later will be affected. Now, before I go into the game theory based causal AI analytics framework for climate modeling, with the impact of climate change on and the adaptation measures. So till now, what is the means? I just want to put it in a very brief manner so that the clarity should be there. So the domain, the thing that we are targeting is climate change adaptation. The impact of climate change and adaptation. It means the moment we see any impact of climate change, so we'll also see that what kind of climate action measures need to be taken to counter that threat. This is the idea. Second idea is that for that we are saying that let's go for causal AI analytics framework rather than the conventional AI system. Fine. So why? So to understand that why this movement should be there from conventional to strong, that's why that one gist was given that in this way we could have worked on the conventional AI system, or we can work also. Now, from movement to the conventional to the causal AI framework, and that to the game theory. So before I move into this module, the game theory, I would like to now give a very simpler explanation that what actually is missing. Now, suppose the sensitivities that we are taking or tackling in the conventional AI systems or any kind of intelligence systems, it was data driven, and the model that we are talking, that will also be data driven. But the way we are going to handle the process variables will be different in the causal AI analytics platform. And this is not like it's my personal thoughts or something. Right now, I'll be sharing one. You'll be seeing on one slide that Dr. Julia Pearl, who is known for one of the pillar for the Bayesian networks, and plus he's been an awardee of Turing Award, which is like a prestigious award in the world of computer science. So what does he say about causal AI analytics, and why is he like a critic of deep tech analytics? Because you need to teach. There is a quote. I'll be sharing some quotes also. We need to understand that we need to make now machines to decipher the results also. Something is coming out of the black box, and now this is the result. Now, based on this result, you take actions. If this is the way, we will fail sooner or later. There is no other way, because our system is highly dynamic. So many factors are playing role. So we need to take care of that one also. Now, why game theory? So why game theory? I will explain after a few slides. So let's first very brief, and I tried to explain it, put it in a very simpler manner. Then after a few slides, I'll explain that why game theory. And why game theory we are proposing and not proposing, I will be explaining something that we have developed something. So why game theory should be clubbed into in the with the causal artificial intelligence analytics platforms. And there are other branches, there are other models, there are other mathematical frameworks like game theory should be considered. So what actually is game theory? So it's a mathematical framework for analyzing the consequences of certain decision-making scenarios. It means you suppose it's like a game of chess. I am taking some move, my opponent is taking some move. So based on these actions, the outcome of the entire this chess will be decided after some time. So the game theory takes care when there are multiple players, what kind of moves, what kind of actions those multiple players are taking. Based on those actions, what will actually happen? What will be the impact on that system? So the mathematical models, which are specialized mathematical models, which try to address this thing, it's like the USP of game theory. It means now you can relate it. I told that suppose there are multiple players, based on their actions, what could be the impact on the system? Here I'm taking on this the name system. Generally here people means we use games like chess. So I'll be explaining that one also. Now see, please try to relate this one. We are one player in this ecosystem, human component. There are other players like the core, suppose physical components, like the geological components. There are different players in this ecosystem. Based on their actions, what would be the impact on the entire ecosystem? The models, the frameworks which can take care of this interaction can be put into the category of game theory. Now there are different ways to explain this one. That's why I've written like 4 kind of explanations. Science of strategies, which comes under probabilistic distribution. So leave the probabilistic distribution. Science of strategies. Suppose government come up with an idea that no, if we need to control the climate change threat, so we need to do this one. It's one strategy. Suppose some other player, if they come up with some kind of strategy, suppose it's a good strategy that any disaster management authority that let's build some kind of embankments to control the flood threats. Fine, it's a very good strategy. But then suppose those embankments were not built at the right place, the strategy will not be effective. So how is it going to affect? Means the interaction between these strategies need to be addressed by some formal ways. So game theory can take care. Now framework for studying strategy, interactions between players. Now suppose I am trying to do something to make sure that climate sustainability should be there. But at the other side, suppose something is being happened, some kind of like infrastructure activity or something, maybe some very irresponsible behavior of the citizens, which is just in the opposite direction. Now, who will win? Whichever has the stronger force, that the impact of that strategy or action will be visible very sooner or later in that area. Second, studying mathematical models for assessing interactive systems. Means how is it going to interact all the players. Now, so we'll be developing models, but we can't develop models, or we can't develop any approach like that only. There are different ways: cooperative, non-cooperative, symmetric, asymmetric, simultaneous, sequential. So these are different approaches. When we discuss about game theory, I will try to explain it in a very simple. Cooperative game theory. Suppose you are at the other side, I'm on this side. But we have decided that look, we need to work as a team because our goal is sustainability. Let's work together. This is cooperative approach. This is a cooperative strategy. Non-cooperative, you have your own goal. I have on my agenda. No, my self-interest has to be taken care of. But the ultimate idea is sustainability. But suppose we are just focusing on our self-interest, so it's a conflict. Now, wherever resistance is lesser, means wherever the force is higher, that actor, that player will win. Now symmetric, asymmetric, again same. You are on the other side, I am on this side, but we have the equal chances. When we say we have the equal chances to win, means we have the like equal understanding, equal support. Everything is like very balanced, and then we are taking up this journey. So that's like a symmetric approach. Asymmetric means the entire system is unbalanced. I don't have those many resources. You have maybe higher resources, or you may not have a very huge resources. I have huge resources, but we are trying to do something. So our approach and our impact will be different. Now, simultaneous. Simultaneous means I'm also doing something, you are also doing something. But I am not aware what is your idea, means what is your movement. I am not aware about your movement. You are also not aware about my movement. We are doing something. These kind of strategies where we all are taking actions, but we are not aware of each other's move. Then this comes under the category of simultaneous. Sequential means I know what you did, like a chess. I know that what action you have taken. Now, based on your action, I'll be taking my action. So actually, these things happen in our ecological system. So game theory can be like a very, very, very powerful tool to strengthen any ecological models or any. That's why game theory is very, very popularly used in economic models also, social models also, psychiatrists also use psychological models also. Many people in ecology also use it, but it is little complex because of the interactions. So we need to be a bit careful for few things. Now there are few terminology in game theory that when I'll be explaining, so that's why this needs to be understood, like game. So here, suppose it's a situation where firms make strategic decisions considering the actions and the responses of players. That's what I said. Let's put it in a very simpler term. It's a chess. Chess is a game. Here I am all two players are playing. You are taking some actions. I am taking some actions. Ultimately, some result will come. Based on that, it will be decided that who lost. You lost or I lost. So this game is like a situation. So here chess is a situation. If we take choose some specific model or case from the natural ecosystem, so that then we can say that that's a game. I have given one example that how to represent this one. Now, a strategy, either you think in terms of rules. These are the rules. Based on these rules, I need to play or I need to take. Means in this way we can understand. Or the second way, actions. These are the actions are being taken by the players. Now, players, if there is any disconnect, you can replace the term players with the stakeholders. Now, payoff, what is the value? So you are taking some actions. Now, suppose 4 or 5 stakeholders are there. Okay, somebody is building, somebody is trying to restore, somebody is trying to do something else. So many stakeholders are there in a value chain, in any kind of value chain or in any kind of a ecosystem. So finally, we'll have some outcome. Okay, something will happen, either positive or negative. That outcome is payoff, that result. Now, optimal strategies means what? The expected outcome. Suppose we have decided that we will do something to strengthen the perspective of sustainability. So our strategies, the best strategies which can increase the prospects of this our expected result. So that will become our optimal strategy. Now, strategies can be of many kinds. Pure means, suppose like it's kind of a binary. I have taken this one. If there are two strategies, so I have chosen that I will go with A. Then I will exclude B. So it means if I have taken A, then B will be like 0. So probability will be like 1. Mixed strategy means there are 3 or 4. So out of 3 or 4, we have taken means I have taken like a percentage of this approach, a percentage of that approach, and maybe third approach I have left. So it means I have. It's like a calculator. The way we live life. No, I will have this one. Then suppose I am giving one example. We all are a student of science. Suppose tomorrow exam is there. Seven units are there. So you have decided, no, from first unit I will take this. I will go for this part only. Second for this one only. I will leave the 7th one. So it means you are going for a mixed approach. So it's a mixed strategy. So in real world phenomena, mostly the most pertinent thing is that we have to go with the mixed strategies. See, just for so that you can have the clarity, so can have the picture. Here S1, S2, S3. Suppose 2 players are there. 2 players, either you say player or stakeholders. Two stakeholders are there in the context of some event. That event could be anything. Suppose you take it environmental sustainability. Two stakeholders are taking some actions which will affect the environmental sustainability. So here environmental sustainability becomes the game, and those stakeholders become the players. So those stakeholders, there are different, suppose climate action measures. So we have given that 3 climate action measures can be taken, S1, S2, S3. So based on, if I have taken as first approach and player 2, the second stakeholder also behaved in the same manner, then the value is 12. Means it's like a dummy number. It could be anything, some numerical value, just for the sake of. I have taken first approach, but the second stakeholder taken the second strategy. Then what would be the output? These output, suppose the score. Suppose this is like the 0 to 100 score. So on the scale of 0 to 100, suppose if I am taking first strategy, S1, first strategy, and stakeholder is taking the second strategy, then on the scale of 0 to 100, the sustainability score is 41. So in this way, we generate the payoff matrix. Now, positive outcome means what? Gain to a player A and the loss to player B. So these are the like positive, negative, these are the meanings of this one. The last part, this one, like max min principle and min max, we need to take care of this one. Look, when we work on sustainability, these are, I would request everyone that don't think in the terms of mathematics. It's like a very simple rule. So what is max min? It is about maximizing the minimum guaranteed gains. It is like, we always do this one, that look, this is in the worst case scenario also, I should have this. This is max min principle. It means we are trying to maximizing that at least whatever minimum guarantee is there, at least that prospect should be maximized. A minimax principle, it is like risk analysis, risk mitigation. It is about minimizing the maximum losses. Even if flood happens, so this is the maximum loss. Means suppose 500 crores will be lost, or 1,000 crores will be lost, or 2,000 people will be affected. This could be the maximum loss. So what should I do? What should we do to minimize this maximum loss? It's a kind of risk mitigation measures. No causal artificial intelligence. So it means before I go forward, just a little 2 segments. First, I've explained the like conventional AI, kind of we've taken one event, climate resilient agriculture, that can be replaced with any event, whichever suits you. Second is game theory. Through game theory, I tried to explain that let's understand how stakeholders interact with each other in a system. If we really know, if we really understand that how stakeholders interact with each other in a system, then only we can build a robust, sustainable system or robust, sustainable analytics. If we don't have this understanding, and just without this understanding, if we go and develop some kind of analytics which is fully focused on the pattern, it will fail sooner or later, because the demand is rising. We need to take care of this interactive thing. But now the next question is, fine, we'll take care. But then we need to understand that what are the optimal frameworks which can take care of this, kind of dynamics, interactive dynamics. There could be many other frameworks also. So here we are considering like game theory. Now, causal artificial intelligence. So the topic is that game theory based causal AI analytics for climate modeling. Climate modeling in the context of climate change impact, that is in the direction of sustainability, not other model. The focus is on this. So now causal AI. So after explaining this one, I will merge game theory and causal AI and how is it going to impact. So what is causal AI? So before I explain anything, and later on in the next slide, I have actually pasted some screenshots and some quotes and all about the causal AI. The gentleman, means I have personally, I have a soft corner towards causal artificial intelligence, because I believe that if we don't know the regions, root regions, anything is just a, we can say that if you just quantify some kind of pattern, if you say that, look, he's behaving in such a manner, fine, you passed your judgment, he behaved in such a manner or she behaved in such a manner. But actually, if you want to find out the solution, you need to understand, we need to understand how he or she behaved. Why did he or she behave in that manner? So that why is causal AI. This is the soul of any, this has to be the soul of any system, then only we can make anything sustainable. Dr. Judia Pal is, as you can see that he's a like Israeli American computer scientist, and right now I think, if I'm not wrong, he's heading the cognitive the department also. He's the director of cognitive department also, and he has got Turing Award also. And you can see that he is popularly known for championing the probabilistic approach to artificial intelligence. I want to emphasize on this phrase, for championing the probabilistic approach to artificial intelligence. The moment we say probabilistic approach to artificial intelligence, it is a deviation, it is an indication that we are deviating from the black box approach. Probabilistic analysis means you are taking care of the transition dynamics also. Then you can say that in many ways, though in black box also we do, yes, but with constraints, with limitations, everything can't be handled. Now, I have pasted one screenshot. So I don't want to go into the details, but the first line, actually, I like that line. Deep understanding means knowing not merely how things behaved yesterday, but also how things will behave under new hypothetical circumstances. This is the basis of causal AI. There is a movement from conventional AI system to the causal AI system. Just based on the available data sets, we develop some kind of models. Yes, we have done the sensitivity analysis also. Many people confuse sensitivity analysis with the causal analytics. Excuse me. Hello.
Yes, sir, you are audible, sir.
Actually, I thought someone is saying something, so that's.
No, actually, someone has unmuted their mic. Please, sir, you proceed ahead.
Yes, no issue. Fine, thank you. So that is actually key. That deep understanding means knowing not merely how things behaved yesterday, that is available data sets, but also how things will behave under new hypothetical circumstances based on only data sets, available data sets. If we aim to develop solutions, if we aim to develop models, then it may go in a wrong direction. So this is actually basis of causal AI. Now, few of the quotes you see, these I have taken some screenshots somewhere. Why artificial intelligence needs to understand consequences. To build truly intelligent machines, teach them cause and effect. Like this is the repetition. To build truly intelligent machines, teach them cause and effect. This is from Dr. Pearl. I think this is from the book of Why. Now, when we are talking about AI, deep tech and all, the causal AI revolution is happening now. It's very true actually, because if you search right now cognitive modeling, cognitive systems, it is in the direction of making machines to know also, it's not about how to think, to know also that why something is coming, what are the regions, what will happen, what are the hypothetical scenarios. Now, I try to keep it very simple, that when we are saying causal analytics, so without making it very complex, three basic things. And based on this, we can keep going on. Three things need to be taken care of: prior probability, conditional probability, posterior probability. When we are saying prior probability, it means available knowledge that you have currently. Use that. Now, how to quantify that knowledge? That knowledge can be quantified with the available data sets. Maybe we all are student of environmental science or system sciences. So we always say that space-time data sets are there. Last 50 years, weather data sets are there. It means whatever available data sets are there. Based on that data sets, you quantify something through some mathematical framework, through some any kind of informational framework. So you are quantifying that knowledge. So through data driven, if you have data, quantify that. based on expert knowledge. You don't have the data, but someone knows the event very well. He's expert in that. So that inputs can also be considered to generate your prior probability. Prior probability means before I study anything, what I know. What I know, I have to quantify. This is prior probability based on empirical analysis. So whatever I observe, whatever I've experienced, now suppose some local from someone from anywhere, suppose someone from Himachal or someone from Uttarakhand or from Guwahati or Mizoram, anywhere. So they know, maybe we have not experienced those events, but a local light can say, no, we always experience this event in the month of monsoon, and these are the frequency for last 10, 15 years. I have been observing this one. So use that experience also, quantify this one. So this means the journey of causal AI begins with this quantification of the available knowledge. Now, second, before I go for the second, let's jump to the third one. Posterior probability means not just transition dynamics, output. It means the thing that you're trying to predict, whatever be the case. I mean, suppose we want to understand that what could be the impact of flood on the agroecosystem, what could be the impact of landslide on the livelihood, what could be the impact of the glacier melting on the local livelihoods, what could be the impact of any other weather event or climate change event on certain aspect of the society. So based on that, what is the outcome and the transition dynamics. Through causal analytics, transition dynamics is seamless. It means if I say there is a high probability that flood is going to affect agriculture in this way, in this region, fine. But we must have a scope also, that are we 100% sure that this is going to affect in that manner only? If we are 100% sure, then we need to calm down actually, and we need to understand, we're talking about Earth system science complexities. Our last 10 years before, the things which were very relevant, today it's not relevant. The things which were like very happening with a very low intensity, it's not like they're like the intensity is too high. We are not even able to predict it. Whatever is happening right now, we don't know what will happen next year. So this is the first journey, is that quantify the current knowledge. Second, last journey is that the prediction with the transition dynamics. The soul, conditional probability. Why I said soul? We know what happened to us. This is the current knowledge. We know what we're trying to achieve. But the journey now is conditional probabilities. It means what are the factors which may affect that event? What are the factors which actually have affected that event in past? Second, based on hypothetical scenarios. Right now, there are some events which we have never experienced in a region, but now we all will agree that in many places people are like, now it's like a general public discussion. ये तो कभी नहीं होता था. It never used to happen, but now it's happening. It's a general public discussion. It's a hypothetical scenario. It means whatever was not happening, it's happening. I don't know. We don't know in future what other events will pop up, and suddenly we'll say that we never imagined that this will happen. So we never imagined. It means we don't have the data. So if we don't have the data and we have developed some model based on these premises, then definitely that model will never be able to entertain that hypothetical thing that will become a reality in near future. How to handle this hypothetical scenario? Here, at this juncture, game theory comes into the picture. At this juncture, the entire causal AI, causal attribution, the soul of causal AI, where we can, what we say, that we can inject the potential of game theory here, because game theory is not just about that. What is your action and how am I responding to that action, and then what is the outcome? What happens? Game theory also takes care of one more thing, that suppose some stakeholders are there, they're trying to address some problem, but that problem has never been addressed in that region before. Then they observe these kind of events in other regions. Based on that understanding, all stakeholders are taking their actions. It's very simple. It actually happens. We do in daily lives also. Like if I don't know that how that man is going to behave, I don't know my interviews scheduled with that man, but I know that yes, he's that kind of man. I've discussed with 10 persons. He's that kind of man. It means I will plan accordingly that one. It means I never had any real interaction with that. I don't have the data. I have peripheral understanding. Based on that one, I have created one image, one thing that yes, he may behave in such a manner. This is a hypothetical scenario. It never happened. And based on the peripheral understanding, we have created those variables. Here, the understanding from game theory can be used like kind of a bang on for developing conditional variables, and it will also help in the prior probabilities. So the entire journey in a very simpler term, if we really intend to develop a platform, models, look, we need to understand technology will not solve a problem. Mathematics will not solve a problem. These things will help us to solve a problem, but we need to connect the dots. These are tools and techniques. If we create a technological platform, will it solve a problem? No, we have to take care of the soul of the technology also. That is our models and mathematical foundation. This is the soul of a technology. But will it solve and then when it comes to mathematical models, so any mathematical model will solve the problem? No, the soul of the mathematical models on any model are the variables. What kind of variables we are taking? So only considering variables will solve the problem? No. Then we need to take care of that. What kind of variables, process, pattern, what are the relevances? So the entire journey, process, pattern, forecast. So process variables means you take care of the process variables that we were discussing in the very beginning. If you remember that agriculture and this one, that this needs to be taken. This will help us to create the prior probability. When we know why it happened, when we know when we know what is currently happening, this knowledge, the past and the current observation will help us to generate the conditional probabilities. And when we club the process pattern, the function of process pattern is the forecast, posterior probabilities. Now see, to sum up the entire discussion, so game is sustainability. So we are interacting, different stakeholders are interacting in this ecological system to achieve sustainability. Players who? Aberration. Aberration means some stakeholders' actions can create aberration in the ecological system, and some stakeholders' action will create resilience in the ecological system. So conflicting players are in the picture. So these are the players, stakeholders, strategies. What could be the strategies? Climate action measures, LULC sustainability measures, could be some negative strategy also. Payoff, sustainability score. So when you consider everything, based on this one, if you can create the conditional variables and all, and then if we push into the causal AI framework, then we are closer to the, I think I'm running out of time, but I will try to wrap a bit fast. So the entire understanding, so we need to now push it into one platform, that is strong AI-based analytics. What is strong AI-based analytics? Look, see here, I can go into the details of this one, but this will demand some time, so I will try to wrap it up fast. See, the entire thing, the circle, the central point is space-time analytics. Take care of the past, take care of the current, conditional variable analytics. What factors are affecting? Sensitivity analysis and mining. What factors are being affected by what kind of scenarios? Simulation and forecast. This is the soul. How to achieve this one? See the topmost corner, the leftmost, association analysis. We need to take care of physical social factor. Prior knowledge engineering, what happened in the past. Second, you see the topmost right corner, functional mapping, socioeconomic cognitive mapping. We need to understand that how population will respond, how people will respond to the measures. Then impact quantification. If we directly go for the impact quantification, it's not going to solve the problem. Then discrete time evolution analysis. At what state, at which state, that evolution from one state to another. Then the last is state-based evolution analytics, projection perspective. Then we go and say that, yes, these could be the precision measures. The entire knowledge base, which will be generated from this one, will push into the causal AI system. And then what will happen? We can identify the actual climate action measures. For here is Assam, because you have been doing this impact study on that one right now, and formulating seamless implementation plan. Second, deciphering responsible process variable for causing climate aberrations in Assam. Assam can be changed in any region. The entire thing is what? Impact analytics. Now you see the variables, process variables, then pattern variables, then forecast variables. And if you can see these, I have already joined. When you go for process variables, these blocks need to be taken care. When you go for pattern variables, these blocks need to be taken care. When you go for forecast variables, these blocks need to be taken care. And the entire understanding on one hand, river morphology, terrain dynamics, land system profiling, we need to quantify the physical parameter. But on another hand, demographic dynamics, socioeconomic profile, cognitive mapping, because different stakeholders are part of this ecosystem, we need to take care of all stakeholders. Now the entire thing is, I will skip this slide. All I want to say that the entire thing is like, you need to take care of the local variables. Everything has to be quantified into different channels, hotspots, probabilities, hotspots, exposure area, differential vulnerability, again, the population mapping, the response variables, risk quantification in terms of physical, social, and the local variables need to be taken care of. These all understanding actually will be pushed to this causal AI framework, because you are strengthening the process modeling. And then within this one, to make it seamless, this has to be done. Not just one event, here first event, second event, third event, if you can see this one, because we are talking about the impact of climate change on a region, on a system. So only one event is not affecting. There are n number of events. For n number of events, we need to do the transition analysis, the analytics, then the hyperlocal scenario, then risk quantification. Then what are the triggering point? In one region, at certain rainfall, flood can be triggered. But at certain rainfall, some other event will be triggered. Those things need to be quantified. Now, based on all these understandings and everything, we also developed one platform, PICStack, which is for the resilience and sustainability. And as I said, that I take delight, and on the behalf of team and everything, right now it is being like showcased here also in the Trade Expo event, also in the International Trade Expo event, which is being now held in the Greater Noida. Very soon we'll be releasing the things in the social media also. That as whatever we have discussed, you see PICStack constitutes the what's, the how's, and the why's of an event. The why's is actually causal analytics. What is PICStack? It is an actionable AI platform. Means it actually takes care of that. It is like a stack of pixels. When you think of PICStack, either you can think in terms of a stack of pixels or a stack of precision insights, where each pixel, each insight is derived from climatic events, ecological events, socioeconomic, cognitive events. Then the cumulative impact of those events on user level, not at pixel level or something, user level. At one location, different people can be affected in different intensities. This is the entire idea of PICStack, the solution that we are telling and trying to develop. And it's like a core research-based product. And we are going to, that's why I've already mentioned that we have been engaged in like 16 states. We are trying to do some kind of impact study. So the entire idea is intelligent, insightful, and actionable. We need to understand that what kind of actions need to be taken care. I would like to mention one thing, that to develop these things, we can develop, but it may not be effective. So spatial agent-based AI frameworks, human in the loop ML frameworks, cognitive modeling, very absolutely necessary. Causal AI frameworks, explainable AI frameworks, these are necessary. The entire sustainability has to be taken care of in these 4 blocks. Climate smart events. Which event is relevant in your region? First, this has to be identified. Risk intelligence. What is the intensity of that event? Third, environment and ecology. Then, if this event is relevant in Gautam Buddha Nagar, then what is the risk associated with that event? If this event happens, what is the impact of that event on the environment and ecology? If this is the impact, how is it going to affect the sustainability? So that's all for now. Thank you so much. Thank you so much for giving me the platform to
Thank you so much, sir. And you talked about your mission of your company and the products like the PICStack in the field of the climate change and sustainability. And you also talked about the human-centric solutions for the climate change, sustainable solution, climate action plan, and sustainable development goals, disaster management. You have talked a lot in your lecture about the carbon footprint also, how we reduce it, and the reasons and the factors behind the climate change and the food ecosystem, climate resilience, carbon footprints, mitigating climate action plans, game theory, terminologies, strategies, and in a very elusive way, sir, you have talked about in your lecture. And sir, there is some question in the chat box also pasted. One question is, I am reading for you. How might Earth's atmosphere, land, and ocean system respond to changes in carbon dioxide over time?
It will change negatively.
Negatively.
If we are discussing right now net zero, the target is this one, and we are discussing that if we don't that climate clock, if we don't act in that regard, so what is net zero? We need to take care of the like footprint and the sequestration. If this balance is not there, it is going to affect very severely. And this question, I take this up. I'm just taking a little opportunity through this question. And when we are saying that how is it going to affect this one, I had one discussion last time in the Amity University also. That there also I said, look, all these discussions are very good and everything. Without taking care of the supply demand, these things cannot be taken care of. That's why we are saying that the entire dots need to be connected. Climate smart events, risk intelligence, and its impact on the ecology, and then sustainability. This is like a value chain. This is like this balance has to be there. So it will affect negatively if we don't take resilient measures.
Correct, sir. Correct, sir. Thank you, sir, for answering the question. Another question is a simple question, but yet we can think over it. Is it too late to prevent climate change?
Look, technically, academically, scientifically, research written, it's all in public domain that let's work it out, and we have like 4 or 5 years left. If we don't take pertinent action towards net zero, then the entire climate change phenomena will become irreversible. It can't be achieved. So technically, like 5-6 years, we have this time in our hand. But let's put it very honestly, it is too late if we don't change our lifestyle. If we think that we will talk on the climate change, but we'll be like live a luxurious life, and climate change will be taken care by someone else, it will not happen. I was discussing on some other day somewhere that even we are sending that email also, so it's like energy requirement. We need to take care of if it is not needed in any context, if it's shopping is not required, don't go for shopping. If it's not required to use some luxury item, don't use it, because it's all energy systems. The costs are hidden. So it is too late if we don't take care of our lifestyle. First, take care of the soul, then it will be taken care of.
Thank you, sir, for answering the question. Last question is like, the concept of the green building, sir. We are living in an urban agglomerate, and what you can suggest, like how the implementation is further needed so that we can promote many constructor and contractor also. They should also like go for green building concept. What do you say on that?
We all live in Noida. One thing I like about Noida is that whenever I go from office to my flat is near expressway. So on subway lanes, I see neem trees.
Correct. Yes,
so whenever I see those neem trees, I thank that urban planner. What happens? The green building is okay, fine, but take care of the core botanical aspect of also. Just planting trees will not help. We need to understand we are those entities who are responsible for carbon emissions and carbon footprint. And actually our natural covers are sequestered. But the way, suppose I can run 100 meters in 5 minutes, suppose just. Other may can run in 2 minutes. Someone will take 10 minutes. It's a potential also. In similar manner, natural covers have different potential to sequester carbon. Every plant will not be helpful. Every tree cover is not helpful. So I always quote this example that once I saw in some area, I will not quote or something, I saw eucalyptus trees there. It's a very ill plant thing. It is going to affect the groundwater potential there. But in terms of forest cover, we have forest cover. But what kind of forest? What kind of plant? Take care of the sequester also. What kind of carbon sequester we are going for?
Sir, very, like what I say, I'm also like thinking in the same way what tree I should plant in future also. So that idea should not be to cover the greenery and the green Delhi, clean Delhi. It should be like we should also sequester our carbon in a sustainable way. Sir, thank you so much. And in future, we need some collaboration also from your organization. Thanks a lot, and thanks for coming on Amity platform. You really have given the passionating lecture also, very enlightening lecture. Thank you, sir.
It is my honor, and I'm very thankful again that Amity University has given me a platform to share my thoughts. Thank you. Thank you so much.
Thank you so much. Moving ahead. Everything is theoretically impossible until it is done, as rightly said by Robert A. Hallane. So for this quote, I am like now invite Dr. Maya Kumari ma'am, who is an assistant professor in Amity School of Natural Resource and Sustainable Development, and she will provide the hands-on training on the theme fifth on climate modeling and projections. Ma'am, we welcome you on Amity platform. Dr. Maya Kumari ma'am is a professional with diverse experience in the field of geospatial technology and environmental management with an experience of 11 years in technical proficiency in software proficiency like the ERDAS, Imagine, ArcGIS, QGIS, SPSS, Google Earth Engine, and this geospatial mapping and modeling. GeoProcess with the ESRI model builder application of remote sensing and GIS in remote resource management and monitoring management, mapping and modeling. Digital imagine process and satellite imagine enhancement, digital cartography, global positioning system, and she is working as an assistant professor with Amity School of Natural Resource and Sustainable Development, Amity University, Noida, Uttar Pradesh. And she has taught so many digital imaging process course in cartography, global positioning system also, spatial data analysis also, modeling, application of remote sensing and GIS in forestry, agriculture, environmental issues. And now she is guiding the student for dissertation work on the topic related to the role of remote sensing and GIS in environmental resource mapping, prepared proposals for the organization. And now she is also assisting and preparing the study materials on various topics of for IAS and IFS training workshops organized by Amity University. She is the nodal officer of the institute, various ranking and accreditation activities, and administrative activities also related to student supports and welfare, and internal quality assurance sales coordinator also she is working with. Now I would like and request the team to please play the felicitation video of Tulsi Sapling for the ma'am, who is our professor in our institute. This is a symbol of Amity University as a lifelong bonding and friendship. We welcome you, ma'am. Over to you,
So
ma'am.
much. Thank you so much. So considering the background of the participants being from the UG and the PG background, so whatever I have thought of demonstrating today will be right from the scratch. I will be telling the students about the software which they can use whenever they want to have it in their study. And then I will tell them how to download a satellite image on which they can work. And then I will be demonstrating how they can go for calculating a land surface temperature of a particular area. So it will be a kind of basic steps, which is involving about the software downloading and installation, and about the data which they can use for it. So let's start with the softwares first. The software which I'm going to tell today is basically about the QGIS software. So this QGIS software, so let's first talk about the softwares which are available when we talk about working in remote sensing and GIS. We can say that this software, they are the heart of GIS. So whatever we are working in GIS, whatever the decision we want to make in GIS, that is only possible with the help of the softwares. So if we talk about what are GIS softwares, they are basically the sets of module which is used for performing different activities. Let's say, for example, digitization, editing, overlaying of the data, networking, vectorizing, or conversion of one data to the other form. And finally, the aim of all the GIS softwares is to produce or generate an output. So there are several types of softwares which are available, but on primary basis, we can say that there can be two types of softwares on the basis of their availability. So one can be your open source software. It means they are freely available, and you all can see in the slide, there are a few listed open source softwares which can be downloaded from their respective websites. So like Viva GIS, Grass GIS, Elvis, Map Window, OpenJump, QGIS, Saga GIS, White Box Get. So these are certain open source GIS, and today we will be talking about QGIS, which is an open source GIS. QGIS is also known as Quantum GIS also. But on the other hand, there are certain softwares which are basically licensed softwares, which are used for processing remote sensing data or for making any kind of decisions. So the paid ones are basically ArcGIS, ENVI, Geomatica, GeoMedia. Then we are having ADAS Imagine and all, Global Mapper. So there are certain softwares which are licensed one, and for that we need to buy them. Now coming to the Quantum GIS, how we can download and install QGIS on Windows. So specifically, whatever I will tell you, it is with respect to Windows. But one of the advantage of having QGIS is that we can have it on the Mac systems also. So when we talk about what basically QGIS is, it is an open source geographic information software, which you all can use it for the free. And it is an open source application, which is providing us different functionality and plugins so that whatever the data we are having, we can view it, we can edit it, we can store it in a form of a database. And whenever we want to analyze it, we can do that. So with the help of this QGIS, we can create different kinds of map. And as I have told you, it is available for Windows, Mac, and it is as freely available for Androids also. Now, how to download this QGIS? Before downloading, one thing which we have to check is our computer's architecture. It means you have to see what is the bit of your system. So you have to see whether it is 32 bits or 64 bits. And the simple way is that you can right click on your My Computer and you can go to the properties of that. And there you can find what basically, what is the architecture of your computer. But generally, if this, you can say nowadays, whatever the systems or the hardware which we are having, they are almost of 64 bits. So nowadays, if we talk about 32-bit system, they are of no use. They are not in use today. So mostly we have to focus on the softwares which are of 64 bits. Then the next thing which we have to choose is the latest option. As we are having different versions of different gadgets or smart gadgets, if you will say, because whatever the things which are getting updated, according to that, the version of that particular device is getting renamed. Similarly, when we talk about QGIS is also having several versions of it, like QGIS 2.18 to 3.16 and several other formats are there. So you have to choose for the latest one in that. And if you are using Windows, then you have to download whatever the software which is for the Windows option. Now, how you all will start downloading QGIS? First of all, you all will go to the browser or in a Google, you will type qgis.com. And when you will click on QGIS, when you will open this page, you will get an option of download now, which will be a green button. And from the download page, you can choose the version of QGIS. So the things will be much more clear if you will see the screenshot here. So once you will type qgis.com, you will get the option of download now. This download now option, when you will click on this download now option, you will get several options for downloading the QGIS software. And as this QGIS software is a unique software that is available for, as I've told you, for Windows, Mac and all. So out of that, you will choose the software which is for the Windows, and you will get 4 options for that. So this kind of screen you will get when you will opt for the QGIS for Windows. So you can see this is for 64 bits, this is for 32 bits. So you will get for each of the versions, if you will see, you will get options for 64 or 32 bits. So you have to choose the bit which according to the architecture of your system. Now, once you have downloaded, what you will have to do, you have to click on whatever the software you want to download according to the specifications. Once it is downloaded, you have to double click on the installation file that you have downloaded on your computer, and then you will start installing it. Now, once you have started downloading, you have to read all the agreements and then you have to click OK so that you can move further. And then you have to check the default installation path. So whatever the folder path will come, you have to leave those things as it is, because whatever you will be doing, all the things will be getting by default, it will get in the C drive. Now I'm going to play one video that is a guided video for the installation of QGIS. So this video will basically help you to see whatever I have told you with the slides. This video will help you to understand how basically this QGIS is installed. So basically what we have to do here, we have to write download QGIS and QGIS.com, and then you will get the options like latest release, which is basically the latest one, then long-term release, which is more stable. So you have to choose out of them what you want to go for, whether you want to go for the latest release or anything which is basically a long-term stable one, right? So you will get a message like, thank you for downloading QGIS and all. And at the left bottom, you all can see the QGIS software is getting downloaded. After that, you will open the window, the folder where it has been downloaded, and you will double click on the installation folder, and you have to go for the simple steps. You have to check on the license agreement and all, and you have to go for the simple steps of OK, next, and installation. So after that, the installation will start happening, and it will take a few minutes to get it completed. And it is as simple as you are installing any of the software on your system. So it is simple steps through which you all can install the QGIS software. So this process will take few minutes, and after that the software will be installed in your system. So you can see once it is installed, you will get the option of QGIS. So you can go to the programs and you can see the QGIS desktop. And when you will double click on the software will start, and the interface of the software will be like this. So it is as simple as the Microsoft products you are using, like Word, Excel, or the PowerPoint. You will see all the options which are available here. They are almost the same as any of the Microsoft products. So you can see whenever we are having a QGIS software, which will open, you can see on the left panel, we will get all the options of all the drives which we are having in the system, and all the folders which we are having in the different drives. So through this, you all will be able to install the QGIS software. Now, moving forward, now I'm going to share with you what is the process of downloading satellite data once you are done with the installation of the softwares and all. The next thing is we need data for the processing of it, right? So the satellite data which we can use for any kind of analysis, or you can say mapping, how we are able to download them, right? So I'm going to tell you about the process through which we can through which we can download it. So first I will explain the things on the slides, then I will be doing it practically so that I can be able to tell you how we can do it, right? So in this particular slide, it is basically divided into two parts. One will be basically a download of the satellite data. And the satellite data which I'm going to tell you about is Landsat 8. And this Landsat 8 data is freely available. That is why I will be explaining about that. And then the second part will be estimation of land surface temperature using Landsat 8 satellite image. And why I have chosen this land surface temperature, because all the sessions which is held earlier, it is on climate change and all, and temperature is one of the key ingredient, if you will say, which is playing a very important part related in climate change, right? So when we talk about the Landsat satellites, Landsat program is a series of Earth observing satellite mission. It is jointly managed by NASA and US Geological Survey. On 23rd July 1972, in cooperation with NASA, the Earth Resource Technology satellite was launched. So, the Landsat satellite was Landsat 1 was earlier known as Earth Resource Technology satellite. And later it was renamed as Landsat 1. So this Landsat satellite, the first Landsat satellite was launched on 23rd July 1972. And till then, till you can say from that particular year, we are having archive of remote sensing data. And there are currently many satellites which are there in the space, which are actively working. And right now, if we talk about the Landsat mission, the Landsat 8 and 9 is currently active. Now this Landsat program, as I have told you, that it is continuously archiving the information of the land changes and whatever the information which is trending right from 1972. And if we talk about this particular mission, it is world's largest, or you can say the longest continuously acquired collection of space-based moderate resolution remote sensing data. And the people around the world are using this Landsat data, not only for the research and business, it is also being used for education and other activities. Now coming to Landsat 8, if we talk about Landsat 8 is having 11 bands. And these 11 bands are basically, if you can see, they are the ultraviolet blue band. Then we are having the blue band. Then the third is the green. Fourth is the red band. Fifth is near infrared. 6 and 7 are short wave infrared. 8 is basically panchromatic. And 10 and 11 are basically your thermal bands. So basically, if we talk about the bands which are there in satellites, they are basically talking about the sensors which are there in the satellites, which can record energy in these particular wavelengths. So today we will be talking about these bands, basically band 10 and 11. If you will see these band 10 and 11, they are thermal infrared bands, which can help us to know about the temperature. So we, whatever the demonstration I'm going to give you today about the land surface temperature, I will be using band 10 and 11 for that. Now, before that, you should be aware about the Landsat series or the sensors. As I have told you, it was the year 1972 when the first Landsat was launched. And you can see the sensor which was there with them was MSSS. And this Landsat 1 got decommissioned on 6th January 1978. Then Landsat 2, it was from year 1975 to 82. Then Landsat 3 was there from 1978 to 83. Landsat 4 was there from 1980 to 1993. Landsat 5 was there from 1984 to 2013. Landsat 6, if you will see, the launch date and the decommission dates are same because this was a failure mission. The satellite was not able to achieve its orbit. Then we had Landsat 7, and you can see it was launched in year 1999, and it got decommissioned last year only on 6th April 2022. Landsat 8, which was launched in year 2013, it is still active, and the sensor for that is OLI and TIRS. So right now we have discussed about it, like OLI is basically the bands which are the optical bands, the blue, green, red bands, and TIRS is thermal infrared bands, which is band 10 and 11. And recently the Landsat 9 was launched. It was September 2021 when Landsat 9 was launched. So these are the series of Landsat data which are available. And whenever we are having, we want to study anything about, let's say for 1980s, we are having the option of many of the satellites right from 1 to 5. We can use them to know about what was the situation on the Earth in the year 80s or 90s. And if we want to know anything which is currently happening or how the things are changing right now, we can we can use the data which is Landsat 8 and 9. So as I was talking about the bands, you can see, as I told you, it is basically indicating of what wavelength the sensor is able to record the energy, and these numbers are basically indicating, the band number, or you can say the part of the spectrum for which they can record the energy. Now, how we can download these Landsat data? For that we have to, one of the sites which you all can use for downloading the satellite data is that you can visit earthexplorer.usgs.gov. If you are the first time user, you have to register yourself. And whenever you are registering yourself, it will ask you several questions, like for what purpose you want to download the data, for which sectors you will be using it, and also you have to give all the details while registering yourself on this particular site. Once you will register yourself, you will get an email on your registered email ID, so that you can verify it and you can use it further. Once the registration is done, you can log in, and on the search criteria, you have to type the name of the place for which you want to download. Like if I want to download any satellite image pertaining to Bangalore, I have to type Bangalore. So you can see this kind of interface you all will have. So here from the search option, you will get basically from this you will get the option. From this search option, you have to type the name of the place. Once you will write the name of the place, you have to click on show. So once you will click on show, it will show you the place which is basically pertaining to Bangalore. So here you can see the page will be highlighted and it will be indicating to the place which you have written down with its latitude and longitude. After that, the next thing which you have to decide is the date range, right? That means for which year, for which month you want to download the data. So you have to specify according to your requirement, because in certain studies we generally go for seasonal study. So we want data for a particular month. So accordingly you have to mention here, or you have to choose a particular month for which you want to download the satellite data. And if it is a yearly study, you have to define the years according to that. So right now you can see here the place name is given and the data range has been given as 1st January 2000 to 23rd March 2015. So depending upon what kind of study you are doing, you can do that. Then after that, you have to select the data set. It means which satellite data you want to download, and you can see you will get these many informations, or you can say the list of the satellites from which you can download the data. So like I want to go for Landsat 8, I will check on Landsat 8. And once I have decided with the place, date, and the satellite data, I will click on results. So you can see I'm having this option of results. When I will click here on results, you can see I will be getting the options of all the options, or you can say the images which are pertaining to Bangalore area. And you can see you will get the ID of that image, the coordinate of that particular image, what was the date on which it was acquired, and path and row number basically indicates while the sensor has captured the image of that particular area, what was its number when it was moving around the earth in terms of its row or the, you can say, column number. So you can see whenever we are having any data, we are getting these many options. So if you will click on any of these images, you will be having information about it. So a picture which is having a JPG kind of symbol, when you will click on it, the entire image will be flashed over here. And a paper like symbol is there, which will give you idea about the metadata. It means the information about that particular satellite data, you will get it from here. And a green downward arrow basically indicates the option for downloading the data. Now, when we say, when you have not logged in this one with your registered email ID, you will not get the option of with this green downward arrow for downloading it. Always, whenever you have to download data, you have to log in. So once you have decided that which scene you want to go for, you have what you have to do. You have to see the metadata, right? So when you will see the metadata of this, you will basically, once you have decided which metadata, which scene you are going to download, you can check the metadata of it, right? So what is its latitude, longitude, the sensors and everything. Once you have verified everything, the another thing which you have to verify is the cloud cover. The cloud cover you can see is 0.02%. So any image which is having a cloud which is less than 0.5% is generally preferable for any kind of study. If the cloud cover is more than 0.5%, then we have to discard it, or we have to move further with the other scene. Now, when you will click on download, you will get these options. So you have to go for the entire GeoEye data product. You will click on this download option and the whole data will be downloaded. So what I'm going to do is that I'm quickly going to show you in the system that how you all can download the data, right? So you all can see basically whenever you will type in Google earthexplorer.usgs.gov, then you will get the option here like login. So when you will click on login, you will get the option of login with your registered email ID. Like you can see it is saved here for me. And if you are a new user, you have to click on create new account. So when you will click on create new account, you will get, you have to fill all the informations. And once you will complete the whole new account creation, you will get an email on your registered email ID. Once you will verify it, you will be able to use it. Because it is already done for me. So what I will do with my registered email ID, I will sign in. And remember, as I've told you, if you have not signed in, you won't be able to download the satellite data. Now here, first thing which we have to do in the search criteria is that we have to write the name of the place for which we want to go for. So in the drop down, you can see I have clicked here where I'm having the feature. I will click on address place, right? So in the address place, I will write, let's say the work which I'm going to do right now will be on Gautam Budh Nagar. So let's do it for Delhi. Sorry. So you will click on show. So once you will write Delhi, you will click on show. Now you can see I have got this information about Delhi. Now when I will click on this Delhi, the part of Delhi will be shown here on the right panel. So what I can do, I can enlarge this part by scrolling the mouse, and you all can see this is basically the Delhi part, right? Now, once I have decided, now I have to go for date range. So I can click on the calendar, like I want to go for the Feb data. I will go for Feb, 1st Feb 2023, and I want to go for till March 2023. I want to have the data for 2 months. So I will take 31st March 2023, right? So here also we are having option to choose for the month. So I will uncheck all of them because I have already decided for this. Now, the next option is data set. So which data you want to go for, right now I'm telling you about the Landsat. Apart from that, you are having several other options for the images also. So you can see you will get the option of Landsat here. So you have to click on the drop down. Here you will get the option of Landsat collection tool level 2, Landsat collection tool level 1. So what we will do, we will go for Landsat collection tool level 1, and when you will click on the plus sign of that, you will get the option Landsat 8 and 9, right? You are also getting 7, 4, 5, 1, 5. But because we have decided that we have to go for 2023, so I will be going with Landsat 8 and 9. I will check on this, and then I will click on results. So once I will click on results, it will search for the scenes, the satellite scenes, which is pertaining to that particular area. Now you can see that these many images which we have got for this particular area. And you can see this is for Landsat 8 and 9. Now, as I've told you that you will get the ID of it, the acquired date. It is 30th March 2023, and the path and row is there. If you will click on this particular sign, it will indicate or it will show you the image of that particular area, right? And if you will click on this particular page sign, it will give you the metadata of this particular area. And you can check for the clouds and everything, that how much cloud is there. So you can check with the clouds and all. Then you can have idea that how much cloud is there in this particular area, right? So you can see the cloud and all information, you can get it from here. What is basically all the details which are related to this particular satellite image. So you can see the grid size is 30 into 30 meters. So the spatial resolution of this is 30 into 30 meter. So all the information about this image, you can get it from here. And then you have to check for the cloud cover also. Once you have checked, and if it is more than 0.5, you are not going to download it. Now again, I'm going to show you the another one. If I will check on this, you can see it is again having clouds. And if I check on the other one, it is again having clouds. So what I will do, I will go for the another one where I can see this, and it is free from the clouds. Now, if I want to download this one, I will click on this green arrow downwards. So if I will click on this, a new window will open up. And in this, what I'm going to do, you are getting these many options, right? So it is basically the TIFF file you want to download, and the other options are there. So you can go to add all files to bulk or download files, all files now. So when you will click on download all files now, the downloading process will start with all the bands and all. So, one second. So the downloading process will start, and in a way you will be able to download the data, right? So just a second. So this will be the way through which you all can download the data. And you can see here you can see the product options also. So from here also you can download the satellite data at one go. You can go to product option, and you can see the whole data is here. So whatever the data will be downloaded, that will be in a zip folder, and it will be of 1.1 gigabytes, right? GB. So once you will click on this one, all the bands, you can see, as I have told you, there are 11 bands in the Landsat 8. So you can see all the bands right from 1 to 11 will be downloaded, right? So once you will click on download and all, it will take time, because as you have seen, it is 1 GB file. So it will take time and it will get downloaded, right? Now, I'm going to share a folder where you can see how it has been, how it will look like when it is downloaded, right? So you can see this is basically the folder. So if you will see, this will be a kind of zip folder you all will get. And you can see it is LC08 indicating it is Landsat 8. and whatever the date we will have, it is, we will, if we are going from the back, you can see it is also indicating the date on which it has been downloaded, right? So once you will unzip it, the folder will be like this. You have to open it. You can see when we have opened it, we are having B1, B2, B3, B4, B5, till we are having 11 bands. And whatever the other options we are having, they are the supporting files and the information related to these bands. If you will see all the bands which are right now here, they are black and white. But when we will stack them over each other, they will become colorful in a false color, which is basically indicating the different reasons, or you can say the land use of that particular area. If you will see this particular file, which is having extension of MTL, it is basically, you can say, a file which is the metadata file. So this metadata file is a file which tells us all the information about the satellite image. So you can see it basically that metadata file is having all the information about that particular image. So you can see what is the Landsat ID number, what is the sensor ID, which is OLITIRS, spacecraft ID, Landsat 8 is there, what is the format of that, at what time the date it has been taken. You can see it is 16/2/2015, the latitude, longitude detail, all the details related to this will be present here. And you know, whenever we are processing any kind of satellite data, we need certain constant values or the values which are related to images that we can have it from these metadata. So that is why these metadata are very important whenever we are going for any kind of image processing, right? Now, I'm moving forward with the information which is related to, you can say, about the land surface temperature estimation. So how we are going to use the data which we have downloaded for land surface temperature estimation. So let's talk about the theory part of it. If we talk about the land surface temperature, it is basically is the Earth's temperature, which is directly in contact with measuring instruments. And it is usually measured in kelvins, right? So this LST is the surface temperature of Earth crust, where if we say heat and the radiation from the suns are absorbed, reflected, or refracted. LST changes with climatic condition and other human activities. And as I have told you, when we talk about the climate change and all, it is a key part of that. And you know, we know that the worldwide this urbanization has significantly increased. And there has been also increase in the greenhouse gases. And because of that, you know, the temperature of the Earth is rising. So there are, you know, if we want to know about these things through the ground survey method, you know, that will be a very time consuming and burdensome process. Even that will be very expensive also. But when we are using this remote sensing, you know, the things are much easier for us to do so. So identification and characterization of urban heat island is basically done with the help of land surface temperature. And land surface temperature is a key factor for calculating the highest and the lowest temperature of that particular area. And this moderate resolution satellite data, which is Landsat, it helps us to know about the surface temperature. Now, as I've told you, this Landsat 8, it carries two sensors, OLI, that is operational land imager, and thermal infrared sensor. So we are using this thermal infrared sensor to calculate the surface temperature of the Earth. So to start with you can say, the estimation of land surface temperature, first we have to calculate NDVI. The NDVI is known as normalized difference in vegetation index. And it is a normalized difference between the infrared band and the red color band. So if you can recall, we have discussed about the 11 bands which are there in Landsat 8. What we are simply doing here is that we are subtracting near infrared with the red band and dividing the sum of that. So on the basis of that, we will get an image. And once we will get the image, we will move further. So right now I'm going to tell you all the part of the steps of the land surface calculation with the slides, then I will be showing the things in the software. Now you can see when this is a screenshot which basically helps us to know when you have calculated NDVI. This is basically image of Gautam Budh Nagar district. So you can see this is the NDVI image, where you can see whatever the areas which are darker green in color, they are basically the areas where we are having vegetation. Light or whitish color kind of areas are areas where we are having non-vegetated area. So what we have done here, we have calculated NDVI, that is normalized difference vegetation index, which is giving information about the vegetation in this area. And you know why it is important to calculate vegetation when we are calculating or estimating land surface temperature, because you know they are inversely proportional to each other. Wherever we will have a vegetation, a good condition vegetation, obviously the temperature of that area will be cooler in comparison to the area which is devoid of vegetation. The first step which we will start with calculating the land surface temperature will be basically whatever the step I'm going to tell you, it is according to the handbook of Landsat Science Data Users. The first step is whatever the numbers which we are having in the satellite image, what we are going to do, we are going to convert those numbers into basically spectral radiance. And the formula for that is gain into DN number plus offset. Now this gain and offset values, we can have it from the metadata file, which I have shown you right now, right? So when I say about this metadata file, you can see when I will show you in the metadata file, you will find the gain value for band 10 is 0.003342 and the offset value is 0.1. So what we have to do simply here, we will put the value, we are going to put the value of the gain here, and we are going to have the band here, the band 10, which is the thermal band, which is going to help us to know about the temperature. And then here we are going to write 0.1. And whatever the image we will get, that will be telling us about the spectral radiance. So you can see when we will have it in the software, we will get an image like this, indicating that what kind of spectral radiance we are having at these areas. So whatever the areas which are blue or violet in color, they are indicating the radiance is much higher in comparison to the area which are yellow or pale in color. Then after that, the second step will be using the first step, because we have calculated this L lambda, which is spectral radiance in the first step, using the constant K1 and K2, which again, we are going to have it from the metadata file, the word file, which I have shown you. So we are going to use this K1, K2 from metadata file. This we have already calculated. When we will put this formula in the software, you know, we will be able to see the brightness temperature of that particular day, right? So you can see this is a brightness temperature map of that particular area. So you can see the brightness temperature of that particular area is 16 degree minimum and 27 degree maximum, which we can have in that particular was there on that particular day. Once we have done this, the third step is basically calculating land surface temperature. Now, when we are calculating land surface temperature, TB is something which we have calculated in step 2. Again, this is TB which is calculated in step 2. The rho value is already calculated according to user handbook, that is 14,380. Only thing which we don't know is log emissivity, right? So, you know, whatever the temperature we are getting, we are comparing it with a black body. So it is important for us to know the emissivity of that particular object which is under study. So the formula for calculating the land surface emissivity, the formula is 0.004 proportionate vegetation. PV is how much vegetation is there in that particular area, plus 0.986. Now here we are having two constant. Only thing which we require is proportionate vegetation. Now how we are going to calculate this proportionate vegetation? For this, the formula is here we are going to use the NDVI image which we created in the before the first step of LST. So here we will take NDVI image minus the minimum value of NDVI, divided by maximum value of NDVI minus minimum value of NDVI. Once we got everything, we will be able to calculate LSC. And finally, what we will do here, we will put all the values here and we will take the log of it. And finally, whatever the image we will get, that will be having our LST. So you can see this is a proportionate vegetation, where how we have calculated proportionate vegetation. We have calculated proportionate vegetation with the help of NDVI image. So you can see it is indicating what are the areas where the proportion of vegetation is there. So the darker green area is indicating whatever the areas where the proportionate vegetation is more, right? Now you can see this is the LSC calculated. LSC is land surface emissivity. So you can see whatever the areas which are red in color, they are where the emissivity is high, is basically the areas which are basically urbanized area in Gautam Budh Nagar district, right? So once you have calculated the emissivity, then on the basis of the formula which I have told you, we can calculate land surface temperature. And you can see here the lowest temperature on that particular day was 16.56 degree. And the highest temperature which was recorded, because it is basically image of Feb month. So the maximum temperature which was there on that particular day is 26.92 degrees, right? And this is the way through which we generally calculate LST. Then once the LST is calculated, we can identify what are the areas which are having urban hotspots, or you can say the areas which are basically the part of urban heat island. So urban hotspot delineation can be done with the help of this particular formula, where we need to know the mean and the standard deviation of LST. Once we will have this mean, and we will go with the summation of the twice of the standard deviation, and whatever the value we will get, that is going to divide the whole area into an area which is a urban heat island and the areas which are non-urban heat island area. So you can see this particular image, this particular image where we are having LST, and on the basis of the calculation we got here that 22.5 degree is the threshold, which is basically dividing the whole study area into two parts, which is basically the hotspot areas. So here you can see the areas which are basically red in color. They are indicating the areas which are hotspot in the study area. So this is the way through which we generally go for the calculation of land surface temperature in the software. Now, let me share with you the software where I have already prepared a few of the images. So it will be easy for me to tell you how you all can do it in the software. It's the second. So, these are basically the simple calculation we generally do whenever we are trying to study about the land surface temperature in any of the softwares, right? So, whatever the images screenshot I have shown you, they have been prepared in the software, and it is the simple calculation you have seen. It is only the addition, subtraction, or division which we have done, and on the basis of that we have got our result, which is the land surface temperature, and it has basically helped us to identify what are the areas which are the areas which are basically urban hotspots, right? Give me a second. I'm just sharing the software with you all. So QGIS software, yeah.
Time is alarming, actually.
Okay.
close the session
Okay,
also.
meanwhile, if anybody is having any question, you can let me know.
Yeah, ma'am, there is a question in the chat box. Is there any free climate modeling software? Free.
See, there are softwares even for the climate modeling. And, apart from that, we can use these software as well. If you are having a data, whatever kind of modeling you want to do, you can do it in the QGIS software also. And apart from that, there are few other softwares also, which you all can use for climate modeling.
Ma'am, last question for you is which software is comparatively easier to learn in order to analyze the available satellite data for air pollutants?
Okay, if we talk about the freely available data, so Sentinel 5P data, they are available. And if it is related to air pollutant, you can have more information about it. So if we, in general, if we talk about any of the data which is freely available, mostly people are using Lancet. If you talk about air pollution, Sentinel 5P data is there, which all can use it, right? So I think the software is taking time to open up, so I'm stopping it here. And if there is any further question, you can let me know. Otherwise,
Thank you, ma'am. You have answered both the questions very well, and audience has been benefited by step what you have taught about the QGIS software and the Landsat 8 also, and LST training also you have given us. Thank you for enlightening us, and now we can proceed. And this is the time for the end of the session, as the goal of the green technology is to protect the environment and repair damage done to the environment in the past and conserve the Earth's natural resources. Green technology, of course, has also become a bargaining industry that has attracted enormous amount of investment capital. So now we end this session with the vote of the thanks for every audience and the person of eminence who have given the lectures also. It is my deep sense of gratitude and the satisfaction that I stand before you to offer a heartfelt vote of thanks for gracing this session of the certificate course on green technologies for mitigating climate change, organized by Amity Institute of Environmental Sciences from 29th August to 29th September, organized by AIES in hybrid mode in collaboration with the IMD, Indian Meteorological Department, New Delhi, and led Next Tech India Private Limited. This event embarked the beginning of the transformative journey towards the understanding and addressing the pressing issues of climate change through the lens of innovative green technologies. At the outset, I, on behalf of Amity Institute of Environmental Sciences, would like to convey my deepest regard and heartfelt thanks to Honorable Founder President Dr. Ashok Kumar Chauhan, Sir Chancellor, Amity University, Uttar Pradesh, Dr. Atul Kumar Chauhan, sir, for their contribution and the continuous guidance and encouragement. It is their vision and leadership that has placed Amity University among the top universities in the world. Our heartfelt thanks go to Professor Dr. Balwinder Shukla ma'am, who's a Vice Chancellor of Amity University, Uttar Pradesh, for her visionary and leadership and commitment to academic excellence. She has been guiding and motivational force for all of us. Thank you, ma'am. We would like to express our sincere appreciation to Dr. Professor D.K. Bandyopadhyay, sir, who is a Chief Advisor, FPO, Chairman of the Amity Law School and mentor of AIES, for your enlightenment, sir. Thank you. And your expertise in the field has brought us a unique perspective of discussion, and we are very truly grateful for your valuable contribution. We extend our sincere appreciation to Dr. Roni Rupar ma'am, who is an Assistant Director AIES, for providing us with an insightful introduction to the one month certificate course. Your words have set the tone for the event, and we are very grateful, ma'am, for your valuable contribution altogether, the AIES. You are the best mentor. You are truly, and really, we are very honored and privileged to have Dr. Atul Kumar Srivastav, sir, who was from Indian Institute of Tropical Meteorology, who gave the lecture on aerosol, major sink of the aerosol scavenging process, also water cycle, IPCC report. He has discussed in very elucid way. Thank you, sir, for joining on Amity. And our next speaker, Dr. Akhori Pramod Krishna sir, who was a professor from Remote Sensing Institute of Birla Technology from Misra, who enlightened on the theme of the climate modeling and the projection and give the basic concepts and terminologies like the weather and type of the climate. Thank you, sir, for joining on Amity platform. Our third speaker was Dr. Alok B. Mukherjee, who is the co-founder and the director, product research and analytics, LedTech, Nextech India Private Limited, Noida, UP, Uttar Pradesh. Sir talked about the vision of their company, products like the big stack in the field of the climate change, sustainable development goals, disaster management, carbon footprint, and EI in a very elusive way. Thank you, sir. And the last session speaker is Dr. Maya Kumari, who was from the Amity School of the Natural Resource and Sustainable Development. So she has given the hands-on training on QGIS and Landsat 8 software, which have enhanced our knowledge in software learning of remote sensing and GIS. Thank you, ma'am. They all joined us today as the distinguished guest of honor for today's session on the theme, which is theme 5th on climate modeling and projections. We are very delighted and encouraged with their noble ideas and thoughts on 1-month certificate course on green technologies for mitigating climate change. Their presence has added immense value and significance to our gathering. We are deeply grateful for the time they have invested and the insights they have given and shared with us. Thank you, all of you. Their expertise and wisdom have not only enriched us personally, but also provided us with a broader perspective on the theme for today. We also extend our sincere gratitude to the Indian Meteorological Department, New Delhi, led Nextech India Private Limited for their invaluable collaboration in making this course a reality. Your expertise, support, and dedication have played a pivotal role in shaping the foundation of this learning endeavor. Thank you. Our esteemed faculty members, experts, resource person, staff, and the person associated with this 1-month certificate course, we all like to give our deepest regard and thank you for their willingness who are giving us, guiding us, and inspiring our participants also throughout this journey. Your insights and commitment to share the knowledge will undoubtedly shape a new generation of environmentally consciousness leadership. To our participant, your presence signifies and dedication is very necessary for advancing the knowledge and taking steps towards more sustainable future. Your curiosity and enthusiasm to learn undoubtedly fuel meaningful discussion and collaboration during the course. We express our gratitude to our honored guests, all those who have joined us today to embark the beginning of this course and to all together till the journey of today and hereafter also. Your presence is a testament to the importance of addressing climate change and the role of green technology in doing so. I especially thank the people who have been the backbone of this event, the IT department, media team of the Amity, the team who has worked tirelessly behind the scene of ensuring the smooth organizing of this course. Your dedication and attention to detail have not gone unnoticed. Thank you. Lastly, I would like to express my sincere thanks to each one of you present here today. Your participation has enriched this session and setting a positive tone ahead also. As we journey towards, let's make and impact this course further also in coming week, and the course is about to finish also. The knowledge gained and insights, the lectures shared by many eminent professors also connect us and contribute more sustainable future. Let us embark this opportunity to make a difference, and collaborative work also needed in the field of the climate change. Thank you once again, all of you. And if I forgot anyone, please thank you and thanks a lot.